Sir, we'll wait 2-3 minutes. Hello.
Hello.
Hi, sir. We will wait for 2-3 minutes.
Actually, I'm trying to join through it. It's creating a problem. Let me check.
You're trying to share the screen or you're trying to join?
Just I'm trying to set the audio
Okay, okay.
so that I'll speak through that.
Right now, I'm sharing my screen, so that's why I think after
Okay, no problem. Just
using my screen, you will be able to share the screen.
just for a bit. Okay, you do continue, sir. Otherwise, it's fine already.
Mhm.
Okay, no issues.
So we'll start. Meanwhile, the participant will join because it's a time to traveling. Na? So some of the college are having the closing time 5:30. So they will join up to the 6:15.
Oh,
Okay. So good evening, all the participants. We are in the 5th day of our 6th-day online ATAL AICTE FDP. So as usual, we are having the two session today. First session from 6 to 7:30 and second session from 7:30 to 9. So today we are having with us for the first session, Dr. Tavish Wahidi. So I welcome sir for this particular session. So it is our immense pleasure to introduce Dr. Tavish, an eminent CE professional, accomplished researcher and the industry leader in the thermal engineering, computational fluid dynamics, and the advanced simulation technologies. With the more than a decade of experience across the research industry and the high-end engineering consultancy, Dr. Wahidi stands as a distinguished expert who has contributed significantly to solve the complex thermal and aerodynamic challenges across the multiple engineering domain. Dr. Wahidi holds a degree, PhD, in the thermal engineering from the reputed institute, National Institute of Technology, Surathkal, where his research focus on the supercritical CO2 system, natural conventional loop for flow, and the stability and multi-phase thermal behavior. His work during his period leads to multiple publication in the SCI index journal, such as Applied Thermal Engineering, Journal of Supercritical Fluid, Journal of Thermal Analysis, and the Journal of Calorimetry. His research excellence was globally recognized when he received the Outstanding Paper Award at the MTCEUE conference in China 2022. Professionally, Dr. Wahidi served a lead engineer, CFD and thermal at Citadel CAE Technologies, Bangalore. In his role, he mentored the engineering team, leads the advanced simulation initiatives, and provide the consulting expertise in the sector, including the aerospace, defense, automotive, electronics, schoolings, and heavy engineering. His work integrated the engineering fundamental with the high-end computational methodologies, delivering the solution that optimize the system performance improves, and the reliability improves, and the safety enhancement. His technical expertise accompanies and the impressive for the special tools like including the ANSYS Fluent, Open Foam, and human thermal modeling, then SolidWorks, MATLAB, and the different advanced software. Beyond the engineering and simulation, he has demonstrated exceptional leadership and business impact generating the more than 7 crore of revenue through the collaboration across the government organization and the industry sector. He also actively involved in the technological outreach activities such as a webinar, workshop, and the training program, and the collaborative industrial research. With this strong academic foundation and the deep industrial experience and the passion for the technology-driven innovation, Dr. Wahidi continue to inspire the young engineer, researcher, and the faculty member. His commitment to knowledge sharing, problem solving, and engineering excellence align perfectly with the objective of this faculty development program. So we are truly honored to have him with us today. Please join me in the warmly welcoming Dr. Tavish Wahidi, our distinguished speaker for this today's session. So once again, on behalf of organizing committee, I welcome to you, sir. You are having the time up to 7:30. Please share your screen.
Hope I'm audible to everyone.
Sorry, sir.
Hope I'm audible to everyone. Right?
Yes, you are audible. No
Okay.
problem.
Thank you so much, More sir, for this nice presentation for me and giving me a more, the overall impact of how a man can be. So anyway, so I welcome all the participants who are joining today for this faculty development. I'm thankful to the Nutan College. I'm thankful to Madhu sir, and thank you for the More and this management team who's always called me and picked me as a priority for this faculty development. Last time I was also there for 2 sessions. Thankfully, this time also I'm being invited for this. Thank you so much, sir. Please allow me to share my screen. I think.
Yes, sir. Please.
Let me know if my screen is visible to all of you guys. Is it visible to everyone?
Yes, sir. It is visible.
Okay. The topic but which I have to speak about the sustainable battery thermal management system. Actually, sustainability depends on so many things, not only a thermal aspect. So there are so many things that I have to actually share about this management things. But the only topic that I am going to highlight this today is talking about the sustainable battery thermal management related to thermal, how it will be impactful when you are trying to do the thermal management for the EV vehicles. Now, so for this, I'll give you a brief introduction. I'll try to create some curiosity. Why, what the new trends are going on? Why different EV vehicles are coming into pictures? How they are competing with each other regarding when you talk about the range or efficiency wise, the weight wise, the mass optimization or charging or drive cycle optimization for different tracks. So I'll try to give a comparative study for this. Then I'll take you to the simulation approach because I've been to this simulation industry for long back. So I thought to I'll give you a glimpse how we can do the simulation when generally for any, especially for the colleges where we don't have much facility to do the testing. So what we do when we go for the simulation first, we'll try to understand this and try to validate the result what we got through any existing experimental data or a numerical approach or any analytical method that we do to validate our result. So that I'll try to discuss you. Then few case studies that what we have done, what are different problems what we found when doing this thermal management for the EV vehicles, what different type of sort of problems we got, how the customer interacted with us with the different OEMs, how we solve, what was our approach, how effectively we manage their problems to give them a optimized or effective solutions that I'll talk about. Then we'll try to summarize overall things with the conclusion. Let us dive into the introduction part first. So when you talk about EV vehicles, people talk about the Tesla vehicles, people talk about the BYD especially, although there are a lot of OEMs across the market, whether it is a Hyundai, Tata, some Mahindra, even Skoda, Fiat, everyone are there in the market. When we do the comparison, there is a benchmark when we try to compare our efficiency of the EV vehicles existing EV vehicles with Tesla or BYD. These are the leading uh, leading OEMs in, especially in EV vehicles. So I'll talk about why these two are leading in this market. First, big battery and their efficiency. Not only limited to the battery efficiency, we can think about their crash worthiness rating, how much, when do the crash worthiness rating, what level it is exactly is existing, that we have to talk about today. We'll talk, I'll try to explain you the what extra effort they have made to make a technological breakthrough, what sort of method they have used, what implementation they have made in their vehicles, so that vehicle become very efficient, look very perfectly working, very nice, to the any different tracks. What the technology method they are adopting, that I'll try to just give you a brief. Then environmental impact. People do a lot of simulations, considering this much the heat will be there, this much will be the flow rate will be there, this is the desired drive cycle I'm expecting, this much range I'm expecting. But doing all these impact, people used to forget the environmental impact. The same vehicle, what is working in a level ground, it won't work in a very cold environment. It won't work very in the same way when you drive this vehicle in a hot zone. So we can't neglect the environmental impact on any vehicle, whether you talk about the efficiency of the vehicle, when you talk about any range of the vehicle, anything. So environmental impact is a very huge impact, so that we need to consider when trying to design any vehicle. That is very important thing. Then what is your customer acceptance in terms of whether it is a Tesla, BYD, how they manage their customers in terms of sales, in terms of servicing, in terms of quality. Why we trust on these? These are the different sectors in EV vehicles, which are, or you can say in a generalized vehicle, automobile sectors, that people used to think before buying a vehicle or trying to trust any vehicle. These 3 or 4 5 criteria are very impactful and very powerful points that we need to consider while you're buying a vehicle, apart from the budget and all. These are the technical point I'm discussing it. Now, when we talk about efficiency can be, first thing can be your battery management. That is very important. The topic that we have to discuss, are going to discuss today. Battery management comes with a lot of things, like what will be the battery size, how you compact it will be, how you're going to manage all these cooling phenomena for the battery. Suppose you're doing it for the frequent fast charging, whether you are going for a long drive, what will be your battery range when you're driving the vehicle in a hilly region, or when you are driving in a different track, what type of battery management you should keep, so that your efficiency and everything will be. When you talk about efficiency, the next thing come into our mind is aerodynamical structure of the vehicle. What is the, when we do uh, designing, we always keep what is the drag value, what will be the lift value there, whether you are designing any vehicle, whether it's an aircraft or your vehicle, or even a simple design like cycle. You always consider the aerodynamical structure of your vehicle. So this play impactful a huge role, because the vehicle can topple from the track when it's not aerodynamically perfectly designed. So that is major factor. Second one is your mass optimization. If your mass is more, suppose if you want you want a range to be maximum, you want your battery to be charge once, I'll again charge after 1,000 kilometers. So by increasing battery, we can do that. But is it worth? Is it worth? How, if you increase the battery, the mass will increase. If the mass will increase, the overall the efficiency of vehicle will decrease. So mass optimization is very important. Either you do it designed very perfectly, or you go for a lighter metal design. You try to find alternates how we can optimize the mass, so the mass should be minimum, or not minimum exactly, I can't say the word minimum, optimize mass, so that it will bear all the X factors surrounding impact factor, aerodynamical structure, air velocity, or when you're driving in a high speed, it should withstand that speed. That mass is very important, otherwise it will be blown away by the wind. So mass optimization is very much needed that we have to consider. So efficiency wise, these major factors are very important. When you talk about the crash worthiness, what will be the battery structure will be? What are the accepting rule and regulation going on and cap things? What are different rating that we have to consider? How much high voltage tensions, high voltage condition that you have to keep in vehicle that is permissible as per the NCAP, Euro cap or NCAP acceptance criteria for the automobile. That is very important. So this, apart from this, what are your adaptive resistance and pedestrian safety? These two are also a very important topic. Not, but considering all these efficiency and crashworthiness, while designing your any EV vehicle, that we need to consider these two factors, efficiency and crashworthiness, into mind. Then you design your vehicle accordingly. Now, coming to this efficiency wise, when you talk about the battery management, battery range, all these that I'm going to highlight this is like now in market when we always find there when any vehicle given at advertisement or recently Tata came up with a new design. Okay, the pricing and the new design Tata recently a week ago came up with a new model. So they start publishing, they do the marketing for that. Then they do some comparative study with either their own existing model or any other vehicles. So there is a fight between market where different models fight with each other, and all these they do just to prove how which car is maximum in demand, what they sell, how much they are best selling for the last year or existing year. They do a comparison, and there will be a chart or a graph they draw. Based on that, people start believing, okay, last time Tesla sold 1.9 million cars across the globe or in a particular area, and Xiaomi is coming up with a new model of XUVs. Xiaomi, generally we know Xiaomi as a mobile. They are not only they have a beautiful car with a lot of features and in many affordable price. So although it is not in Indian market right now, they didn't got permission like mobile to be sold in India. They are not got a permission to do in same thing in India right now, but they're trying to come into our market too. So all these comes with some X factor. Either they will highlight, there will be some USP for their product. Either they'll talk about the range, either they talk about the safety, a six back safety or front barrel safety or side door safety, crash worthiness type of thing, or battery, how much if you do frequent fast charging, the life of the battery will come into picture. What is the cooling phenomena? How much HVAC optimization can be done when you this type of battery? What is the stability of your car when it's moving in a very high speed, whether it's a fast track car or a passenger car generally used in cities. All these they do the comparison like Xiaomi did with the Tesla, BYD did with the Model Y or Y3 models. They do a lot of comparison based on their architect or designing, their efficiency, the performance wise. All these become a key factor along with the price they are offering to. Because finally the people ask how much is costly it is. We are not in India when Tesla come into, it will be almost a 30% more charge. It's 30% increased price compared to any other market. So are we able to buy it? This become a very key factor when Tesla come into market in Indian market. So all these factors, apart from the all efficiency, even your price may play a major role in this. So when you talk about the battery, or especially in EV battery, people think, okay, I did a charging for 100 meters, 100% charging is there, and the OEM give us a okay that if you charge is 100% charge, it can run for 100 kilometers. We trust on them and start buying their car or anything, or any two-wheeler or four-wheeler, what we do based on their given data. But exactly it won't be like that. Your battery won't, if you charge 100%, it doesn't mean it will reach 100 kilometer. If your the net value will be around 85 kilometer only. There are losses across this. One loss that people used to always that we have to maintain is a 0 mile. You can't drain your battery to 0%. You always keep your battery at least 6% charge, whether you use a mobile or your laptop or any other device that is runs on a battery. You never try to make it zero. Otherwise, the battery life will get impact. In the long run, your battery may, suppose your battery life is 8 years, your battery may die in the 6 years. And when the battery life becomes 6 years, the efficiency will become 70 or 30% or 70% of that one. So again, it won't be useful for after 4 years. So considering all these losses, the major loss is one loss is your braking protection losses. That is very important. And your zero mileage, like you should keep your battery at least more than 60%. That is needed. All these factors we come, and when you try to calculate what is the exact value, how much we are going to get out of 100% charging, it will be around 85% or 90%. Sometimes less than, it will be hardly or maximum 90%. On an average for a battery like BYD and all, it will reach around 90%. But any other batteries, when you talk about Indian market things or any other global market, except BYD, because BYD is like a king in market of battery manufacturing. They are into battery before making the car. So they are known for the battery manufacturing. They have developed a beautiful design for the cooling system that I'll discuss in upcoming slide, how they beautifully design, and they started selling it to Tesla too. The Tesla battery, the Tesla car is still using the BYD concept. Okay, so effectively we can use only the 85% of your battery, 100% charge. So considering all these factors, we do have to consider all these braking protection factors, zero mileage factor, range charge factors, or drives. Sometimes your environmental impact also play a major role. Suppose you're driving in a very hot region, even though your battery is 100% charged, your drain will be faster because of overheating because of over surrounding heating temperature. That will also play a major role. Sometimes you're using HVAC system. So HVAC system in IC engine, the exhaust, there has a waste energy being used for heating the HVAC system. But in this one, in your EV battery, HVAC is using the EV charging or EV battery power to run their HVAC system. So again, there will be a losses for that. So your high accurate battery management is critical for EV and their safety. So you have to highly do a battery thermal management study. You need to consider all the management factors. It's not only related to thermal or anything. You have need to consider everything when you try to design a EV, a battery for it. Now, so I'll give one more glimpse, like end-to-end some research data that how this EV markets are coming up with the benefit. What people think is, I have to put a question forward to you. I don't know. People say that EV is a go green concept. I don't know. My sometimes I think whether exactly whether it's go green concept. Really, EV is a go green concept. It's a matter of I think it's a matter of debate to all of us. So even you guys has to tell your opinion whether exactly whether this all EVs are go green concept or not. Because in my thing, so okay, my EV is I have a EV vehicle, right? Okay, I don't have emission outside. I can accept this, but to generate, suppose to need to do the charging, we need a charging station. Charging station will get the power from a power thermal stations. If you suppose a city, 100 cars were there. Okay, now all replaced by EVs. 100 EV cars are coming up on the road. So out of 100 watt that city consumes, now we have to make 130. So that thermal emissions that is coming from one center, that also play a major role. So I don't know whether it's a really a go green concept or not. That to be discussed. Everyone have a different point, but don't know. But government consider this EV vehicles as a green revolution or green concept for the especially in the automobile sector. That no emission is there, that your carbon footprint will be less when your EV vehicles are running on a road, and it is very pleasant. There's no sound around when any vehicles pass. It won't look like a car pass through that the way that traditional cars pass. Then the second concept come into picture is the battery life and the second life of its application. Battery life is still important. If you buy a vehicle, your battery will come hardly up to 8 years or 10 years. After, what will happen to this battery? What will going to happen to your lithium-ion batteries? How, whether is it possible to recycle this battery? Is it really possible? What will be the emissions? What will be the environmental impact of this? That is still a topic of discussion. Life of battery or second life of the battery, how much sustainable it is, what will the manufacturing method that we should take into picture. We should do a research on that, so that your EV vehicles all will be in a like a sustainable alternate. And how much transparency and how much transparency that as a OEM you maintain to your customers or consumers. Suppose you promise 100 kilometers in a 100% charging. Is it really providing you? How much transparent? There is some star marks are there that based on this road, based on this condition and all. You know, the determined condition that we use always, long term and condition that is always existing in the market. So all these is a topic of discussion that we'll do, and still will come on when the hydrogen batteries will come to picture, or we will replace it to any other technologies coming up in near future. Now EV vehicles in market become very boom, and everyone is starting trusting, and the price value is also affordable compared to sometimes comparable to your IC engines. All these are topic of discussion that we'll do. Now, few things that also we need to think that I think efficiency and real world condition. That factor already I told you regarding that temperature, like environmental impact of the temperature. When at what temperature range you're driving your vehicle, how much load you are keeping. Again, it comes into picture of the mass, and then the mass criteria, mass optimization, and what and where are you driving your vehicle? Are you driving your vehicle in an urban traffic area, or you're driving your vehicle always in highways or 6-lane highways? How frequently you need to charge your vehicle? That also become a topic of debate. There are some charging losses there. Aerodynamical improvement is needed. How much you can do the improvement? All these data tell us a lot of things that need to be considered when you do or try to increase the efficiency of the vehicle for the real world applications. Now I'll tell you all these information that I have discussed earlier, like whether it's a topic of your thermal efficiency, crashworthiness, or we talk about your aerodynamical structure, or mass optimization, or high voltage testing condition, and cap or your cap, different type of acceptance criteria by the government, set by the rule of government or automobile organizations. So we try to do we should consider all these aspects on mind, and we'll do the simulations. Considering some will do the simulation for the complete vehicle, they do the testing. There are different simulation approach. One has to do the testing for thermal management of the battery. One has to do the crash worthiness. Someone has to do the mass calculation for that. Someone has to do the aerodynamical simulation analysis to calculate drag and lift coefficients for different design, how much feasible it is. Someone talk about the vehicle dynamic stability or simulation. Suppose you change your tire design, how much friction will be there, if you at what track you are drawing, this will become into consideration in vehicle dynamics area, or any other factors that we do before any coming up to any idea that you are putting forward. We should consider the easiest or simplest approach that is not very costly, affordable, and only need the drawback for this simulation approach is it always need a validation. And for validation, there are so many methods that we do follow since from simulation industry. Either you develop a correlation with the existing data of experimental that we have. If you have, suppose, if you have this data, then you try to validate the existing your simulation data with that. If not, try to validate your data by developing existing mathematical model. Suppose x plus y is mx plus y equal to mx plus c is a linear line equation model. If you try to validate your model with this, anyhow, it will be a straight line. So you develop some mathematical model, try to convert this simulation information into any mathematical model that should have already proven thing that you need not, it will be my axiom for you, that is no need not to prove. Either you do in that way or experimentally you do the validation with your simulation data. But anyhow, so apart from all this, someone sometimes have to start that we have to do the simulation to come up with all these ideas. So when you talk about the simulations, what sort of simulation that I'm going to discuss here, more or less, is related to the thermal simulations, because I'm been into thermal field. I'm not much very aware about the structural part. I'm not very sound to any other things like vehicle dynamics, stability of the vehicle, but EV, like thermal, that was my path because I did masters and PhD in thermal. So this is the area that I know. I'm not the jack of all trade. I know only this. So if you talk about the thermal management of the battery, a lot of things have to come into picture. First, what is your battery type? What type of management you want? Either you're looking for the battery runaway condition where battery start burning, or you're looking for because of that heating, your electric motors or nearby high voltage cables may start burning, or you're using a joule heat concept for your surrounding bus and nearby connections, or how much heat is coming out when you're using EV for your charging concept or running your vehicle, how much heat is coming and how much this heat is impacting your electronic system there. Whether your brake cooling is sufficient enough to make your EV vehicles cool, that also. Sometimes deforest, that also become important for EV vehicles. What type of what will be your cabin comfort condition? That is very important when you talk about the cabin comfort. Cabin comfort can not only be limited to how much surrounding cool is there. Suppose your body mass index is different. The driver is sitting all suppose a car, um, five guys are sitting there, and all have a different body mass index. Someone is of a taller height, someone is a shorter height, a male or female, or different location. Everyone has different sensation or comfort level. So overall, to make your cabin comfort, that we need to understand the human involvement in that cabin comfort condition, and sometimes also depend what type of clothing system that you are wearing of. So all these factors become very important when you do the cabin comfort simulation for your car as well as the human sitting inside. Then you talk about the range of the battery, the condition, the life of the battery, how long it will be with you, at what time after that we have to replace. If you are doing your battery charge, frequently charging, your battery size is small. Suppose you have generally in foreign, in some cities we have a small autos that we call tuk-tuk or somehow, I don't know. People use different name. So for that they have a small battery, but though they have to frequently charge if they are using within the city. So and they don't have any braking regeneration options are there, then they have to do the frequent fast charging. If you do fast charging, your battery life may get impact. So all considering all these thing into consideration, we need to consider the simulation for all these, not only to it's not only to understand how much heat is coming up to the battery, so how much heat is impacting to. Suppose you are sitting in a car, your foots are touching to the floor, and battery is kept below this. What type of sort of insulating material that you have to keep so that you should not feel your foot should not feel heat. Yeah. All these become major factors when you talk about the EV and their applications. I think, am I audible to everyone? If any, you have till now, you have any doubts, anything? If my voice not audible, let me know, please. Okay. Hello. Am I audible to everyone?
Hello, sir.
Yes, sir. Audible.
Okay. You all guys. So if you know why it's not coming up, please let me know in between. Okay. Now, moving to the next slide, that we talk about an approach that is called electrical thermal modeling coupling approach. This is an approach where we do the simulations. There are a lot of approaches are there for do the simulations. There's not any thumb rule that you should follow only this. There are a lot of simulation techniques that people use to follow for simulations. One of this approach is your electrical thermal coupling model, where your battery resistance depends on your temperature and depth of discharge, and this because of this, that temperature dependent your heating and resistor chemical reactions give you information. It's like to and fro information, electrical thermal coupling model. So your resistance, that okay. So all these, your resistance become a factor of function of your temperature and depth of discharge, and your heating is depends on your Q square to I square, that I square R, that is the traditional formula that we studied in long back in our school. So this approach is very acceptable and well proven model for your battery simulations. In that case, what we do, every battery has their own features, their own internal resistance, their own mechanism, either they follow NREL model or NTG model or a distributed model. There are different battery models are there in market. So every is NREL model or distributor or equivalent model, they have their existing, the developer or battery manufacturers give you the information about this resistance, the fluctuation of resistance based on temperature and depth of discharge, and then because of that how much heat will come up. So these electrical thermal model is very feasible and a fast way of approach to do the simulations generally. Now simulations modeling can be very easy. You don't have to put much on this. You have to select what type of thermal modeling scenario you are into, what type of modeling you wanted to. Okay, so this become, either you have to choose what type of battery model is exactly your, whether it's a pouch model or prismatic or cylinder size, what type of battery it is actually, and what type of vehicle integration happened there. It is a hybrid vehicle integration or it is a complete EV vehicle integration. What is your concept of doing simulation? Are you looking for cooling optimization? What is your agenda there? How are you looking for a fast charging condition to calculate the battery life cycle, or you are into battery thermal runaway condition, that you're trying to understand how much heat is coming to each cell, then trying to understand the how much heat is getting propagated from one cell to nearby cell. That become very important. Second is your what type of approach you are wanted to. Either your simulation is a transient bed analysis, where you're interested in each time distribution of heat from one time to other time frame, or you are only interested in a steady state like final values. So all these become the way of simulations. And what will be your approach? Are you looking for a drive cycle, means a realistic drive cycle, like where you can define the track, uphill condition, downhill conditions, or what you call city driving conditions or a normal driving condition, realistic driving condition, to understand what will be your drive cycle range, what will be the range, how after how many kilometers, if you are in uphill condition, after how many kilometers that you have to charge your vehicle again. That is, all these things become very important when you do the thermal modeling. You have to define all these as an input, and your area of intention, or what are your exactly area of interest that you're looking for. All these. The simulation approach is very simple. It's not that it's not a rocket science that you have to do. Define all these information. What is speed variation with the track? What is your what is distribution? What is the temperature? Which different time? Your state of charge, state of discharge condition, load conditions. You define current variation information. All you define all this. Based on that, it will give you a temperature distribution across the complete battery pack, or you can also try to understand the simulation with each cell that you can calculate, and also you can understand what will be the, if you do the simulation, it will also give you information on what will your battery life will be. If you do different type, if your cooling is not very optimized, if cooling is not very perfect, what will your battery life? If your cooling increase with this percentage, or you start a different type of coolant, what will your battery life and all that. That information will come into picture when you do the simulation. The simulation is a very simple and approach that you should know what type of battery model you are using, what is dimension there. You can do the modeling. You design the battery, to give the battery characteristic, all the information into that. You color with that information through an Excel and pull that information to the simulation environment, to that GUI where that simulation start running. You can also speed up your simulation by adding a HPC pack that make your simulation. If you are looking for how precise you are looking for your answer, what is your agenda, that also define what type of physics you are trying to put into this picture. That also define your time of simulation. How precise you are looking for, what is your either the transient or steady state. All these come into picture when you do the simulation, and you will get a results according to your simulation inputs that any simulation does. Okay. Here, all these considering all this, I'll discuss few case study, and also discuss. I'll share with you information like what will be the simulation approach when you do. I told that simulations approach is very comfortable and you can do. Only it needs only a matter of few help that will guide you how to do simulations. Nothing very tough that only a specialized or a knowledgeable person can do. You should know the method. If you know the method, what will be the approach, or what will be the blueprint of this that you can follow, and you can have your own case, or you can develop your own modeling method, or sometimes you can automate. You can club with any automation tool. You can write a code background simulations, any Python scripting code or existing supporting script. You can modify the existing code to do the automation and try to get a maximum different results, so that it will be helpful for you to get a new research information. It will help you to write a research paper articles that can be available and add on information to the research society. That also we can be possible. So I'll give you some information like one of the a study that is a study that was related to thermal runaway case. We all know this thermal runaway case that is very important when we do the simulations. So a thermal runaway can is a what exactly it is. Is a if you all guys are already aware, so I'll give you a glimpse just to recall my memory. And so it's like unwanted heating is coming out due to any unwanted heating coming because of any mechanical failure or electrical failure or any chemical reaction happening inside. So because of that, your temperature increase. There's an increase in temperature of the battery. It may happen due to the your like overcharging. It may happen due to a short circuit, so it may happen due to ambient condition. What will be happen? It will start your cell start burning. You might find in some videos starting now. I think long back around 3-4 years before that, you may find that scooter or a bike, anything is you find our people start burning. That burning video that we have calculated in our mind, it was a thermal runaway case. Technically, it was a thermal runaway case. So when you find a thermal runaway cases in the battery, what sort of strategies we have to use? What we should do? Why it started burning? What happened exactly? That means whether because of impact, because of hot ambient condition or short circuit, or what exactly it is happening? Why it happens? How much heat is generating? So that we need to understand how much each each cell is generating heat. How much time it will take to completely burn your all the battery pack cells. How much heat is coming out? How much temperature is coming out? We need to understand the passenger safety regulation nearby. If the start, if suppose it blast, it may damage the nearby vehicles also. Some day before, I found a vehicle. You can remove the battery with a single push button. Suppose your battery started burning, you just push a button, your battery will eject, come out from the existing frame, and your battery will move a little bit forward, and your battery will be down, so that the man sitting inside won't be harmed because of this battery uh, ejection. So my question is, suppose in running condition, you just start burning, Just by pushing a button, your battery, you remove a mass of the battery. Complete. Suppose your battery is 100, your vehicle is 100 kg, and you remove 30 kg of batteries. Because of remove of the battery, all of a sudden the dynamics of vehicle may also change. The vehicle may topple there, or you may, or the battery is coming out backside, may hit the backside vehicle. Is it a right idea to do that? Is it right idea to do that? This is again a topic of discussion. Although you can save your vehicle, but I don't know whether how much you save. You're the main sitting there in the vehicle, or a backside the coming car coming from backside, or whatever. So this is again a topic of, but again, this is a topic that people make you think. Okay, by pushing a button, you can remove your battery, you can save your car. I don't know. I don't know whether it's a good idea or a bad idea, but it is an idea that at least save your battery, start getting harm your vehicle somehow. Okay. So that we need to understand how much heat is coming, how much temperature is that coming, that we need to understand in thermal runaway cases. So in that case study, we talk about in terms of simulation. First, you try to understand where you kept your vehicle. You need to understand the underbody structure of the car, and how much the size of your battery vehicle is. What is the size of your battery? What type of battery are you using? Whether it's a cylindrical cell or a pouch lever cell or prismatic cell, and how much? What are the different uh, like motors or tension cables and all are getting attached to this? That is also important. You need to also consider, if you are into mass optimization, that you also need to consider what will the weight of this battery, how compact it is arranged in this, whether how much closely they are closely packed. That is also important. And what type sort of cooling strategy you are putting backside the vehicle to supply the coolant across your battery cell. You need to design all these before a geometry has been which is designed, considering all these cooling factors or battery type of battery factor, that you need to define the battery category as sometimes people kept went there in this conditions, like suppose people this cell start burning, some gas has to move out, so they provide pressure vent, they provide a venting position there, that will designing all these doing simulation that we can consider. And this way look is a very simple design. It's not very complicated. Simple designs are very simple. The complication start when we jump from simulation. We jump from CAD to mesh. Generally, mesh plays a significant role when we do the simulations. Meshing always create problem. We can't go for a structure mesh throughout. Sometimes we can't go unstructured mesh. Sometimes some areas where that you need a refined mesh. Some location that you have to define inflation layer there. Sometimes you have to go for very boundary layer mesh condition that you are interested in. So all these, and how much refine we have to do. And every time when you do the meshing, the mesh number of, suppose you did meshing and you come up with n number of million cells. So my question is, how we come to know that this mesh, after doing mesh, suppose you have got 100 million cells, okay, so or 10 million cells, whether this number of million cells are the perfect cells that we give you me a simulation result perfectly, or is a grid independence mesh. So when you do this meshing, wherever, if there is a thumb rule, like it's a thumb rule for any simulation engineer, we need to do the grid independence study. Every time you need to change the grid size, you need to change the number of mesh and try to find the difference of uh, number of mesh from n to n, n1 to n2, n2, n2 to n3, and trying to find out how much difference you are coming up. When the difference is minimal, so that you can neglect the upper higher values, that we need to do to understand this mesh is the perfect mesh, this mesh is a grade independent mesh, that we can accept this result. What we are going to do, it will be a acceptable one. Anything? Whatever. Uh, Someone is asking something. Okay.
No, sir, no.
Okay. Okay. So I was in a mesh. Okay, I'll give you the thermal runaway case study that we did. What exactly it was, I'll give you a brief information. So it was a 24 cell prismatic cell battery pack. Okay, we used a CSV file for to understand the battery behavior with different resistance and different depth of charge. Did the geometry and meshing. Objective was to understand how much time will it take when you trigger one cell to go to thermal runaway. We intentionally make our triggered one cell, we give them maximum heat so that a cell can go run away. Then we'll try to understand how much time it will take to completely burn this cell. This one was our concept to understand our understanding how much heat and how much heat is getting propagated from one cell to another cell, and the complete time when your cell start burning. First objective was to understand this. Second objective was to how much we can, what sort of mitigation technique we should use that you um, uh, battery should not go run away. And the limitation that any our customer kept us that he don't want it to, he want a comparative study with without any cooling, just to increase the by changing the material or increase the thickness and all, or putting some insulation material in between so that your heat should not get propagated. And although all nowadays you will find there is a minimum safety criteria already kept into picture, like your battery should not burn before 5 minutes. That is called as 5 minute safety rule. Every vehicle get tested or get a passing certificate or a pass certificate from any automobile industry that any EV vehicle I'm talking about, they should follow 5 minute safety rule. Your battery should not burn within 5 minutes. It will give you a time to all the passengers sitting inside to come out from that vehicle, take the important things out from their vehicle. Okay, so all these they make this as a mandatory criteria accept. So okay, so considering all these 5 minute safety rule, and the customer wanted us to understand the impact of insulation thickness between the various cells in by increasing into ratio of 2 to 4 to 8, and how much at what thickness your thermal runaway stops. Okay. Now, our objective was to understand the complete behavior of this. This was the case study that we did. Okay. Apart from that, one more thing was there. Suppose your heating is very high, or your battery is emitting very high temperature, coming with the high heat. What will happen to the floor? Floor. How much heat is getting absorbed by the floor? Suppose a man sitting there, how much it will feel, upper circle will get heated up, what will be the temperature there? That was also a worst case scenario that people, when we have to understand this. So this was the approach that we did. We did a modeling that I discussed earlier. I did a modeling for a battery. We defined what type of battery, but it was a prismatic cell, 24 battery prismatic cell. We put the config file, like which define the battery characteristic based on their depth of discharge or temperature and this approach. And we did an thermal coupling approach. And we're trying to understand when, and we intentionally make one cell. This is the last cell. I think my cursor is visible to all. We make this cell, intentionally make this cell as a, we call this a cell 1, and we started numbering it from 1 2 3 4 5, and last this one is 24. Okay, we sequentially numbered all these cell one by one, and we intentionally make this cell to go run away by putting a temperature around 900 degree plus. Okay, although the cell may go run away after 700 degree itself, but we 300 400 degree itself, even though, but we intentionally make it to run away around 90 degrees Celsius. We trigger this, we call this as a triggered cell. Then we try to understand how much heat is getting propagated from one cell to other, how much it will take a time to reach the heat to be at 12 cell, how much time it will take to reach the heat at 24th cell, although this is a nearby cell to the triggered cell. We'll try to understand this. We found that there are different calculations here. So we found that our first cell, the nearby the second cell, was went to the run away at time of 1.9 minutes, and immediately after that, your before your third cell, your 24th cell got run away in 2.5 before the third cell. So all these impact cells that you heat propagation, that cell 2 started burning first, then started 24, then the sequentially all these cells. Okay, 2, 3, 4, 12. All these are different. All these colors are different cells color and timing that tells us how much time each cell took to go run away. Although this complete complete battery set will go run away within the 5-minute time interval. So this is not a suitable battery to be used in EV vehicles. We need to come up with an idea so that your battery should not run away, or should not run away within the 5 minutes time period. So we did. It was a thickness between these two cells part was 2 mm. Now we try to increase it to 4 mm. And okay, one more thing that we try to calculate the temperature of the floor when your battery goes run away. And initial the temperature was around 500 degrees, more than 500 degrees Celsius, without putting any insulating material on the floor. When you kept between your steel and carpet, when you kept a polyhydrogen foam in between as insulating material, the temperature comes around 55 or something, around 75. Even though this temperature is very high, it's not comfortable for a man to put up like that. So we try to just understand when the battery goes run away, how much was the floor temperature along with you some simulations of battery run away. Now we increase it to 4 mm. We'll try to understand when you make it to run away at 4, what will happen, how much time it will take your one battery to other battery to go run away. It will find your second cell goes run away at a time of 3.4. Although there is an increase in before it was 1.9 minutes. Now the second is because of increasing the insulation, increase the thickness. Your second battery is run away at a time of 3.4. And then there is sequence of burning and your complete third cells run away at 4.8. So still it shows that your cells started burning, from one cell to other cell started burning within the safety category of 5 minutes. So this approach, that 4 mm is not acceptable, 4 mm thickness is not acceptable. So we need to come up with other thickness. So we jump into 8 mm. We jump into 8 mm thickness. We'll try to understand this sequence. We triggered our cell 1 that goes run away. Okay, this triggered run away. Then after that, there is no run away. You find cells 2 run away after 5 minutes. Before it was initially with 2 mm thickness, it's about 1.9 minute. Then you increase the thickness 2 to 4. It went to run away at 3.4 minute. When you make it to 8 mm, your cells run away after 5 minutes. So we can conclude this. Find even in picture you can find the difference. There is one trigger that second cell is not getting headed up. Okay, so we can say this with 8 mm we can stop the runaway cases for this prismatic battery of 24 mm, 24 cells prismatic cell battery pack. So this is the method to make a cell without providing any cooling method to go run away. Same thing we did it. We did to understand how much heat is coming up for your different flow temperature. Okay, what will be if you keep insulating thickness? What will the temperature with 2 mm to 8 mm? That we did a comparative analysis and we kept the same temperature scheme. That because the temperature of second cells is very less now, even your flow temperature is also less. You can find the difference. The high temperature, low temperature. You can find this very comfortable, around 305 and all, comfortable 33, 24 degrees, 30 around 35 degrees Celsius. That is an acceptable temperature for floor. Same thing we did a simulation analysis for same runaway cases. with prismatic cell by providing different cooling techniques. One was just to provide a wall insulation surrounding. First, we did the base analysis, how much time it will take to go and run away. This we did the analysis. Then we do the analysis for simulation by putting the 8 wall thickness. It goes run away at 12 minutes. It goes run away within 5 minutes. Then it goes run away within 12 minutes by keeping it to 8 thickness. And then we kept this insulation thickness at same as 8 and then we provide external cooling. Backside will be the external cooling inside this backside of the battery. So it is going run away at around 30 minutes. So these are different strategies, different techniques that you can use to make your battery safe and follow the strict 5 minute safety rule, or you can can offer a customer a perfect batteries that won't go or run away. So these are different strategies for relative thermal runaway. Now I'll take you to other case study. This is different, just an example, like prismatic cell runaway cases, like potch cell, how these cells look like, all these different. That might you have find these cells in your um, old battery wala cell that you may have find all these. These are different batteries that you have to will do the understanding the runaway cases. Now, this is very standard case that is called a fast charging condition. Suppose you have a vehicle, taxi scenario that I'm going to discuss. The small battery, one cell battery of 20 ampere hours. That is a one condition is simple that you drive for 1 hour, then you do a 15-minute fast charging, and you do it for 4 times. So repetition: 1 hour city tire driving, 1 hour CVT driving, 15 minutes of fast charging, and you do it for 4 times. Again, so 1 hour city driving, you do a normal charging, 2 hours of normal charging. Before that, it was fast charging of 15 minutes. You do a 2 hours of normal charging, and you do it for um, 4 times in a day. So based on these two conditions, like one is a fast charging condition, one is a normal charging condition, what will be the health of the battery? What will be the age of the battery that we need to understand? If you do the comparison between the temperature, for because of fast charging, the temperature is very high. It may tick up to 60. That actually the normal condition has to be between 20 to 30. But generally, in this case, temperatures are very high. And when you do the comparative study between age of the battery, if you do the normal charging condition, your battery will be around 5 years something. And you do the fast charging, your battery may decrease to 3 years. So you have more or less 2 years of loss. In that case, exactly to be precise, it is 1.8 years of loss. So this is the condition when you do a fast charging frequently for 15 minutes for small cell battery. So what should we do so that we can increase this battery life cycle and we can use still we can do the fast charging. My intention was to, I can't avoid fast charging because I have to use it frequently. So I have to do over fast charging. That is my limitation. That is my constraint. Can even though my maintaining this fast charging, can we make my battery life to be little bit nearer to the normal conditions? So that case, in that case, what we did, you have to go for the cooling. What type of coolant you have to use? How much HVAC condition, HTC condition that you have to put? So that will start doing this different analysis. We do fast charging condition by putting your HT's condition of 10%, 10, and we try to understand how much difference is still by doing a fast charging. We achieve almost 0.7 years of benefit. Then we did cooling. We increase the cooling. We increase the cooling and make it to HTC 40 or 20 to 40. We found that your battery life is increasing. Even you are using in fast charging condition, battery life is not getting hammered much. So different cooling strategies, different, even though you can replace with a good coolant so that we can absorb the maximum heat coming out from the batteries, and it will be very useful to make your battery life longer, at least when you compare to with the normal conditions, operating conditions. These are different techniques, and we almost from before it was we have a loss of 1.8 years loss. Now we can achieve only, we have achieved 1.4 years of benefit. That means only the loss is 0.8, 0.4, almost 4 0.4 years of loss. So we have a this in this way we can, even in a fast charging condition, we can achieve the same battery life by providing a normal good cooling conditions with high coolant, good quality of coolant by different cooling design. We can do some adaptive design. We go for cooling pad design with a generative AI design. That also we can. This is a good way of designing battery pads that your maximum heat can be removed easily, or we can also locate where heat is coming high. That area we can target and we can remove that area. Being the supply, we can design in such a way that maximum heat can be removed from that particular area. So this all come based on understanding and doing the submission analysis in the initial stages. This is also very starting interesting case of plug-in hybrid that I'll tell you to this way. You have kept your battery system just above your exhaust system. Battery, you kept this battery system above your exhaust system. So because of when exhaust is coming up, that this heat is getting imparted to battery, and while running the battery also give you emit the hits. So how can you control this battery? So these are the condition. I'll give you this information. Like this is your exhaust system, and we kept this purple color or white color you find in this battery pack integrated just above this exhaust system. You can visualize this image. Okay, so when heat is coming out through the exhaust system, it's getting hard. Receive a heat. You can see this because of exhaust system. Your exhaust, your battery's temperature is very high. Thereby, heat cells are getting absorb all these temperatures. So in that case, what we should do so that your heat should not be get observed to all these conditions. Uh, okay, so this become very important, and we did a insulation. We use the insulation technique. We covered this battery with insulated material and all, and we try to save the exhaust gases or exhaust heat coming out to the imparting to the battery can be minimized. In that case, we give a shielding. We use a shielding technique in a hybrid vehicle so that we battery get not get damaged or because the exhaust gas coming out. We provided a shield about a shield kind of thing above this gas complete gas exhaust system to avoid a thermal runaway gases or a battery, and because of that also we increase the battery life. Now this is a very interesting case again. HVAC estimation, HVAC optimized for electric buses, where it's not only intention was not only to optimize the battery performance, and it was also objective was to understand the cabin comfort of a human sitting in the car in a bus. And this is a case where in buses you will find there are multiple stoppages are there. Every time it will run for 10 minutes. You have to open your gate. People will come in. Passenger will come in. Passenger will go out. And there are multiple occupants are sitting there. Um, multiple doors are opening and closing. So, and even in that condition, suppose you're running a AC buses, so your battery power is getting consumption, getting back up by HVAC system is using consumption is very high for almost 40% battery capacity being absorbed by the HVAC system. So considering all these urban categories uh, to the battery operation for high range, providing comfort and considering all these door opening condition, multiple time of doors of opening and multiple occupants are sitting there. How can we make our cabin or inside humans sitting there comfortable? That was a very challenging thing that we did. So in that case, we did a lot of analysis simulations. So we need to consider the environmental impact on human, at what environment you're running your vehicle, how much solar ratings are coming, what is the ambient temperature is there, how much humidity is present there, what at direction of solar loadings and diffuse radiations, your like Dyson reflected, urban glow type of things that also come into picture. Your direction of the wind, your wind speed, all these environmental come into picture when human sitting there. Considering all these factors, we did a modeling for a human sitting inside, and we did the simulations with different body mass index, like 50%, 25%, like all these humans sitting inside are like a different occupants of different body mass size. Some is taller, some is a bulky one, some is a very thin one. All these, we consider all these factors while doing simulations, and we did the simulations, and we try to calculate the human comfort and sensation based on your Berkeley calculations. Berkeley is a proven method developed by Zhang of Berkeley University. They develop a standard acceptance criteria for a human to be comfort and sense how much sensation the human is feeling, what level of comfort human is feeling. Based on they develop a one mathematical modeling for this. So we use that mathematical modeling, a proven mathematical modeling, to understand these simulations, how much will be the range, how much human is sitting there with the different body mass index, which one will be more comfortable. Those who near sitting nearer to the AC vent, or those who are sitting far away from the AC vent, or what would be the sequence of the sitting, which one is comfortable more, which one is comfortable less, what is the sensation level of human, which part is getting overall comfortable is there or not, which part is getting more sensitive, whether they are feeling chill on the head or hand or foot. So that we consider all these doing the simulations analysis. Simulation. So you can find this driver seat, passenger sitting in different area. We can find that uh, where passenger feeling cold, driver feeling comfortable when driving at this speed. What is all guys sitting there is not comfortable, or who is comfortable feeling comfortable more, because driver is doing some activity. So that also came into picture. How long is driving this vehicle? So the duration of the activity also matters a lot. That we also do the consideration when do the simulation. That is very a complicated simulation that I can put on, but it's a possible simulation that we can do, and we can understand each human behavior's comfort and safety, the way you define the human setting of different mass and different time when a door is getting open at different locations. So that we do simulations, and it was like a great achievement for the term of simulation field. It's really a complicated field that we did a simulation for us. Or one was very interesting, but I'll try to summarize in a little bit fast way, because it was like a drive cycle simulation where we need to understand we have a different track speed, different track where you sometimes you go very high speed, sometimes you go at a low speed when you're driving a city, or if you're driving into highway. That also matters a lot. That where you have to define the battery capacity, complete max ratio, gear ratio, your areas, coolant chiller capacity. All these we define, and we take in all these consideration. We define the speed ratio for time versus speed, how your speed getting variation. All these are different drive cycles. So you can find the city driving conditions very abnormal. Those who are from Pune or Bangalore, they know how it's difficult to drive in a city. And when you do the same driving at highway, we don't have to do much fluctuations were there. You don't have to put your brake frequently. So there is a difference between city drive and highway drive. We did that. We collect all these data, put into the simulation information, and suppose, and we do also consider the regenerative conditions with regeneration and without regeneration. While doing braking, heat is getting generated that we use for cycling, charging your battery, and sometimes what your drive's condition, what is the path where you started and how you're going up in conditions, and at what how much kilometer that you have to charge your battery. That we consider all these complete drive information, realistic drive information to do simulations, and considering all this fluctuation. We understand how much heat is coming into one bed, how much heat charging is there, how much heat is temperature coming, how much voltage is take, what is the state of charge, discharge. Based on that, we can guarantee the range of the battery, we can understand the life of the battery, we can understand the depth of discharge, we can understand the temperature of each cell, the complete battery pack, the floor temperature, or And we can also calculate after how many kilometers that we need to charge. That you should put an alarm that after 5 kilometers you need the charging this station won't be there. Some alarm type of thing that you need to recharge here only because after 10 kilometers there is no charging station nearby. That is some AI technique that we is defined during that one. That is like vehicle condition that we could do for simulation. That is also possible doing simulations. All these some automation technique that we do, like background work for specifying all these transcendent conditions. We did some steady state simulations. We did a CFD thermal coupling for doing all these derived simulation data and impartation. Specify some signals that we define doing simulations, and we completed in automation for this, so that next time on we easy for us. We did calculations for each battery with cooling, without cooling, ambient conditions, light detection, range calculation. So all these are the like output of the drive cycle simulation. So with this, I am closing my this presentation. I hope I'm able to deliver the message that I'm aware of. Let me know if you guys have any questions and all that I can help. So,
Yes, sir. Thank you for the nice session, informative session. We all knows that for the today's word, we required all related to the EV vehicle and the electricity. So I think you have presented nicely that battery. Hello.
yeah, I'm able to listen, sir.
Yeah, yeah. So sustainable battery thermal management for the EV vehicle, and most important, thankful for to you that is you are sharing the all the results whatever you are having. So mostly the speakers are not sharing the result, but you share the all the results related to the battery mode, then simulation, then some case studies whatever you are showing. That is really useful for our speaker, those who want to work on the battery thermal management system. So now the time to interact with our today's speaker. Request to participant, please unmute yourself and you can share the thought with our today's speaker.
I found some Sundar Murthy. One question is asking, can we
Okay.
implement EV modeling through MATLAB? Yes, we can do the EV modeling for MATLAB. That is very, but MATLAB always provide you 1D information. Excellent way to do, but people generally prefer other tools also. Although you can use MATLAB, it's not a bad idea, but you need to do a lot of codings to get a complete information. But it is possible to do the EV modeling. But people generally prefer for vehicle dynamic stability for MATLAB. They won't prefer generally for MATLAB for thermal management. But yes, it is possible. You can do the EV modeling with MATLAB also.
So one more question from the Sundar Murthy. How to implement the AI to analyze EV?
AI is very interesting. Now people talk about AI. We come with a new idea that is called not artificial intelligence. Now we are moving towards artificial intuitions. For artificial intelligence, we need a machine learning as the base for AI. So you need a lot of data to make a decision. AI to make a decision. Artificial intuition is something that is like a trigger point. After this, it won't be like this. It won't be. It's like a what you call in a white and gray, white and black information that we generally do in artificial intuition. Yes, AI help you to generally AI help you in lot of way. Doing the understanding the behavior of your vehicle, like a driver is, suppose your driver is driving a car, start taking some nap or getting dizziness, or your vehicle start getting stopped automatically, or some vehicle is trying to take a wrong turn, all of a sudden is coming into picture. There will be a brake system. All these into come into picture. Even if you talk about in terms of thermal management, I can suggest generative AIs. Like generative AI will help you to design your cooling pad. It will give you information how you can do a manufacturably possible design, manufacturably possible, so that your battery efficiency there, because there is a temperature gradient across the battery pack. There's no uniform battery. it's not a biot system that we saw. It's a temperature gradient. In somewhere the temperature is very high. If you do the simulation, or you do the simulation by designing on putting your concept, sometimes we made a lot of mistakes. So generative AI will help you to give you design so that that particular area will receive maximum coolant, less temperature, so that your temperature gradient won't be much. It will be a perfect design for battery.
Sir, with the continuation of previous question, can we get the data from open source if we use machine learning or deep learning?
What, sir?
In the continuation of last question, the same faculty will ask.
Get data from open source if we use machine learning or deep learning. Can we get data? Yeah, data nowadays, data is like a easiest thing that people can get. Now data become open to all. So just you need to know where the information source is. To be honest, data is not now no more a hidden thing. Information is no more a hidden thing. Just you need to know the where you have to hit the button so that you'll get information. Yeah, it is possible, but you have to do R&D in particular. I may not be expert in that area that will give you exact keywords so that you can start typing and you'll get all the information. But it is possible to get almost more than 70-80% data that is necessary for to do almost even an acceptable design, not a precise design. I can say the word acceptable design. So, but data is possible through internet is very easy to accept. Even Tesla every time releases his data. That is also you can take as a reference for some time.
Yes. Sir, one more question from the participants. Nayana Jyoti. Is there any scope of doing the further research work on the thermal management of EV vehicle? If so, can you please specify the area?
So, research, lot of things are there. You tell me a word, I can suggest you so many things. You tell me a design of the battery, you can do. You can tell me a design of a battery coolant method, you can do. You tell me the size, material selection, design of the battery, changing the complete pack design or a size of the battery. A lot of things are there. Every time, if there is a lot of scope, always a lot of scope. Not like we are not in a stagnant state in at least in battery right now. So a lot of scopes are there. Just you need to identify two things. By do some research in read some newly published articles. Be in touch with automobile EV industries. You log into that pages. You understand. Read new articles. What they are coming up every time. Weekly they are published. New articles are there. If you do study regularly, you will come to know. You will get an spark. What is left? What is the research gap there? But still, the possibilities are there. That you can find any domain. If you are into materials, if you are into coolant, that you can do.
Sir, one more question. In EV analysis, can we calculate the state of temperature?
Yeah, it's possible. Yes, it's so simple. That what we did. Lot of that I told all these simulation what I have. This was based on the temperature only. We come to know the each temperature of the cell. That is possible, sir. I suggest.
Sir, what is the role of material in the thermal battery management system? And
material play a huge role. We all depends on the material. Any if you change the material, behavior will change. If you add any alloy to any other material to other, that will change, the behavior will change. You can come with any insulation material. You can up with a design of auto layer of the battery modules. We can do lot of material. Still, it is untouched. We thought कि कोई आ जाए so that we'll have a new battery coming up and we'll have a perfectly designed battery model. Still, a lot of options are there. We can do a lot of battery management things. I found few papers. If you tell me, I'll give you a few papers that recently, from last 1.5 years, yes, so many interesting papers are coming up. Recent papers in EV, there how the people are changing the outer shell of the battery, thickness of the material, putting some different type of material that it should not allow heat to pass from one cell to other place. Like, there are a lot of things are there. Materials is like king to us.
Sir, but if we restrict to pass the heat from one cell to another cell, So it will be again increase the temperature of that particular area.
Absorbing what cell will be there. People are coming with a like what you call this phase change material even to store the battery temperature. When bakers are not getting started, it will release the temperature to make you start your batteries from cold shut. That's a lot of things are there. It's not only is that heat observing, even heat can be removed by the coolant passing nearby. That can be possible. So
Yes, sir. Thank you for your answer for all the questions from the participants. So I will share your details with the participants. So in future, if the any participant want to work with that the battery thermal management system, so he or she will be contact to you. And I think
sure, we'll happy to be do a collaborative research. We are ready to sign MOU with all these industries, academic industries that will help us. We do some collaborative research. It will be a no, it will be a mutual benefit to both of us because we can't put a lot of time doing writing papers and all. We can do the simulation very fast. We will give you the result. Writing a paper will be a lot of it will be a headache for us, and
yes,
not everyone is expert in that. In that way, we can do some initial help. We can do some understanding and we can collaborate in that way. So it will be it is very good idea, sir. More sir, really a great idea that one to do.
yes, sir. With this, with respect to on behalf of organizing committee members of this ATAL FDP, I would like to express my sincere thank for accepting our invitation and delivering the nice session within a short period of the time. And I think all the participants enjoyed of this particular session because you mentioned all the analysis and actual results. So that is actually useful for the participants. So thank you once again, sir.
Thank you so much for inviting me. Thank you to all you. Thank you so much. Thank you all the participants for having patience and listening to me. Thank you so much.
Yes, sir. Thank you. Dear participants, I have shared the feedback link for this particular session on our WhatsApp group. So please, it's a request to you, all of you, please fill the feedback. It will be useful for us for the remaining process for getting the certification and all these things. So if for the previous sessions you are not filling the feedback form, I request to all the participants from first day to till day 5 fill the feedback form, so it will be useful for the getting the certificates. As usual, we know that the FDP ATAL FDP are having the examination on the last day, so that examination marks and your feedback both are going to contribute to get the certificate for this particular FDP. So everyone, please fill the feedback. Within 2-3 minutes, our experts will join for the next session, and we will start the next session. Next session is also the good. It is based on the practical application. Sir is having a lot of experience in the renewable energy. Sir is having a lot of patents also. So I request to all the participants, please keep login and enjoy the session with the discussion manner. So just I call to the sir. The sir will join. Welcome, sir.
सर नमस्कार.
नमस्कार सर, नमस्कार.
नमस्कार. सुरू करायचंय?
Yes, sir. सुरू करू आपण. So, dear participants, we are having the next session for this fifth day by Dr. Sanjeev Suryavanshi, sir. So, title of the session is Next Generation Renewable Energy Technologies, Innovation and Implementation. So, it's my pleasure. I'm going to invite or introduce the Dr. Suryavanshi, sir, an accomplished academician, distinguished researcher, and the visionary innovator, currently serving as a professor and head of the department in the Mechanical Engineering Department, SSUPS College of Engineering, Dhule. With an outstanding career spanning over the 32 years, Dr. Suryavanshi has contributed extensively to engineering education, research, technological innovations. He holds a PhD degree in mechanical engineering from Shivaji University, Kolhapur, along with the master degree in the heat power engineering. In addition, he is a certified energy auditor recognized by Bureau of Engineering Energy Efficiency, BEE, Government of India. Dr. Suryavanshi research expertise encompass solar thermal system, sustainable ventilation, renewable energy solution, energy conservation, and innovative energy design, engineering designs. His pioneer work has resulted in an impressive portfolios or some 10 granted patents included in India, US, and China patents, covering the solar fluid heater, semi-spherical solar collector, solar cooker, self-cleaning system, and the pedal-operated mechanical device. He has also filed 14 additional patents, reflecting his relentlessness and drive towards the innovation. So his academic contributions are equally remarkable, with the 20 international journal publications, 26 conference publication, and more than 55 expert lectures delivered across the country. He has successfully guided 450 plus students, including diploma, undergraduate, postgraduate, and PhD scholar. Dr. Suryavanshi has also executed several major funded projects supported by the agencies such as MEDA, District Planning Commission, and Dasal System Foundation. These projects are included the development of solar tunnel dryers, sustainable ventilation module, large capacity hemispherical solar dryer, and mixed axis water tube, each addressing real world challenging with the scalable and high impact solution. His work has earned him numerous prestigious awards, including the multiple Avishkar Award, Outstanding Project Award, then Rotary Rational Builders Award, and the I2OR Innovation Educator Award, and the several top prizes in MET, HTM innovations, etc. So his design and innovation have been recognized not only in the academic circle, but also in industry and the social domains. Beyond the research, Dr. Suryavanshi has actively contributed to the academic leadership in establishing the energy cell at COEP, guiding the interdisciplinary student team, serving on the University Innovation Board, and supporting the research proposal evaluation at AICTE New Delhi. A passionate teacher, a commitment innovator, and a respected expert in the field of sustainable energy, Dr. Suryavanshi contribute to inspire student researcher and the fellow academician. We are proudly honored to have Dr. Suryavanshi with us today to share his insight and the expertise on the renewable energy. Let us warmly welcome to Dr. Suryavanshi for the today's expert session. So welcome, sir. On behalf of organizing committee, I privileged to welcome you for this particular session. So you are having the time up to the 9 p.m., sir. Thank you, sir.
Thank you, Satish sir. You are part of our system long back.
Yes, sir. Yes,
And
sir.
I'm very happy to hear you. Good evening, all friends, all teacher friends. All are comfortable with English only, or sometimes in my mother tongue, that is Marathi. Is it possible? Sometimes.
Sir, we are having the participants from the 17 different states.
Nobody. Then I have to speak in English.
Yes, yes.
Only sometime
Yeah.
the crunch is available. The screen is visible, sir.
Yes, sir. It is visible.
Okay. Once again, good evening and welcome all for this next gen renewable energy technologies. Basically, next generation is the very compact domain, but I will give the justice to this topic. Basically, I am going to present what is the innovation, that is for the teacher, what is the innovation, then some case studies, that is one major presentation devoted to solar dryer cum disinfector, and then his three case studies, that is energy efficient building, that is in building ventilation. That project is funded by La Foundation Dassault System with the 4 lakhs of rupees, and then hemispherical solar water heater, that is, as Satish sir says, that is patented in US, China, and India, and foldable cum portable solar air heater that is to be implemented in military applications. What is innovation? Basically, innovation means what is desirable to users. You have to think as a teacher, as a project developer, and as an academician, what is the desirable to users, what is possible with the available technologies. Nowadays, we have very wide boundaries of the technology solution. We can have a fingertip solutions available, at least for the soft things, and then for the practical application, we can invite the people from the long distances for the support. And then, what is the viable in the marketplace? If you satisfy these 3 questions, then that innovation is really helpful for the society. For the professors from the wide spectrum, basically, my work is devoted to solar collectors only, and that too what in only non-concentrating flat plate collectors. I'm not working in concentrated collectors. I'm working in flat plate collector systems. This is the basic working principle. This is the sectional view of the solar water heater for a sample. Basically, solar radiation enters through the outer glazing, that is the glass here, and then it is entering within the box which is insulated from 5 sides. And when that this is the short wave radiation which incidence on the glazing transmitted through the glass into the occupied space, where you can heat the water, you can cook, you can dry, you can heat the air, whatever the end use. But the basic principle is we have to entrain the short wave radiation, that is solar radiation, and when it is converted to heat energy, it's a long wave radiation, therefore it can't pass through the glass entirely. It is re-reflected back, and we can have a greenhouse effect, and the temperature inside the cabinet increases, and that heat energy we have to utilize for our solar applications. The problem statement for the solar dryer, that is dryer cum disinfector, the challenges are for the domestic need, size, cost, and handiness, and for the industrial application, the challenge is available in the market till date, that is about the capacity, and we have developed it for 1 kilogram, 100 kilogram, 500 kilogram, and 1 ton one at a time loading capacity solar dryer. It's autonomous system. We will see in the later stages. Then the challenge with the conventional either solar tunnel dryer or cabinet dryer is about the uniform drying, because it is not meant for the forced convection drying. It is by the natural convection. Therefore, the limitation is there, and that is overcome by our system. Sometimes when it is used in solar energy base, then 24/7 operations are rarely available. Actually, heat pump based systems give you 24/7 operation, but it's an energy intensive process. And that's why when it comes to the energy, then obviously their energy bill is an important thing. These are the conventional methods of the drying from long back ancient days. This is very funny image basically. That toy tiger is there for vigilance, and this is one of the limitation of the open air drying. And this is the technology which is available in the market for the drying purpose, either by using, some people use solar cooker, some people use solar dryer, but small dryers are not available in the market, and that is domestic need. Now in the nuclear family, mostly 1 kilogram of pulses, dry fruits and vegetables and other drying needs are there. For disinfection also the need is same. This is the problem. If we think wheat or some green gram, basically these weevils, panty beetles, floor bugs, guns in Hindi, or grain borers make the agricultural produce non-eatable, non-germinated capacity. And if we purchase it from market, then these are the methods nowadays used in the market, that is dusting or boric powder, then fumigation, methyl bromide, or sometimes pallet inserted into the mass volume, either in silos or in the bags or everywhere. Another method I came in last month, some pouches are there in the wheat bag, and that seems to be like a powder, grayish powder, but it is also a chemical. And friends, all these methods are carcinogenic and highlighted by the World Health Organization, but still we are not looking for that. We purchase the thing as per need, but when it is purchased on the mass basis and if you store at the home, it get contaminated by all these paste. Why it is not contaminated at the merchant level? Because they are using these type of solutions, and these solutions are very carcinogenic. And believe me, my target of the life is to have the patient by natural methods, disinfection by solar energy, that gives you the increased shelf life of the agricultural produce, starting from the pulses, dry fruits and all grains. If you consider the effects on our health, nausea, vomiting, indigestion, food poisoning, and as said, germination power of the all agricultural produce reduces. Also, if we think about, we are washing the eatables that are coated or some by some practices of chemical usage, then if you wash it and if it goes to the drain into the environment, that chemicals are very harmful for the environment also. Then for costly foodstuff exposed to UV rays effects, for example, the system is not here. The costly word is about the agricultural. Every agricultural produce is costly, dear friends. To produce a single grain, it's very hard for the farmer. And the another advantage of this technology is that there is no exposure of ultraviolet rays to the agricultural produce. Therefore, its aroma, flavor, color, and nutritional content retains after disinfection. Basically, it's a drying cum disinfection. Therefore, it's a dryer cum disinfection. Means the purpose is to reduce the spoilage, prohibit the use of chemicals, then use the non-conventional energy, that is solar energy, or also for 24/7 operation. Sometimes non-catalytic field biomass can be used to heat the water, and then that water is being used to heat the air, and that heated air is being used for drying. And another additional purpose to give the handy, healthy, and ecological gadget to prevent the food spoilage. And after all these 4-5 slides, what's the conclusion? The farmer uses the chemicals, pesticides, some त्याला आपण खत म्हणजे that all inputs, some food supplements for the agricultural produce, all are chemicals, but still it's a limitation, or it is very hard for farmer to produce the agricultural product without the use of all these things. But after that, in the supply chain, we have a threat and we have to cut that threat, because it is not in your hand to stop the farmer to use the unhealthy things, but it is in your hand to have the product produced by the farmer, it comes to your thali. If you compare with the chemical, open air and conventional methods, as I said, it's a carcinogenic, health effects, then nutritional values, taste, aroma, then color. All these things are due to open air drying, and also by conventional dryer, there is very less dryers where the multi-layer polycarbonate is used as a glazing, then some UV filtration is there. Unless an total UV filtration is there, we can't stop the color, aroma, flavor, and nutritional value its deterioration. Also, open air drying and other dryings having requires attention, periodic cleaning, and therefore the limitation. That's why the dryers are not commercially accepted by all the farmers and industrialists. In solar drying, another problem is that if you dry it open air or even in conventional dryers, that threshold temperature is very essential to disinfect the product. And for that, basically the air change is very crucial. If you restrict the air change, then the temperature inside the dryer is above 60 degrees centigrade. And as per the medical science research, total viable count research, and all food research technology says that if you withhold or hold the agricultural produce up to 60 degrees centigrade and 30 minutes, then disinfection is there. And that temperature cannot be achieved in open air drying. And also, if a conventional dryer, if there is no controlled airflow, it is very hard to have that temperature. In hemispherical solar dryer, as I said, ultraviolet exposure, then color, the air change, as I said, automation is possible with the hemispherical solar dryer because the air changes at the single point at the crest. Then geometrical advantage, volume to surface area ratio is highest for the hemisphere. Therefore, the drying volume is higher for the given solar aperture. And as its shape is hemisphere, it utilizes morning and evening solar radiation. Therefore, there is no need of tracking of the solar collector. Basically, for dryer, there is no tracking, but the inclination is optimized with the latitude plus 15 degrees centigrade, as the aperture glass is inclined towards due south in the northern hemisphere. But still, such type of design gives you hardly twice in the year the optimal performance, because there is hour angle and declination effect in the solar. Therefore, it's a cosine effect. And in our hemispherical solar dryer, the morning, evening, and even from the year-round system, March to June and June to again March, February, March, we can have a good solar insolation capture, and therefore we can collect the good heat energy, and therefore it's energy efficient system. This is the color comparison. One another thing with is the rehydration capacity. If you dry the thing in the shaded region, that is without exposure to solar radiation, then its color is retained, and also its rehydration the capacity is also retained. If you dry it in the exposed sun, then outer layer may be cracked, and therefore its rehydration reduces. In 100 kg system, we have dried the neem leaves. If you compare, this is the color change of the neem leaves. And for the small 1 kilogram system, we have tested 11 samples of the pulses, rava, maida, groundnut, and other whole grains. Here we have at the left is a rapid prototyping model making from polycarbonate, data logger, pyrometers. Both are in direct radiation. Basically, it is just for the photo, and all temperature thermocouples are there, and it is investigated for a long duration. And when you think after the when I will purchase half kilogram of product, half is as it is put it in the jar, and second one after processing, where they're drying and disinfected, it is stored for the 3 months. And if you observe, if you don't treat it, do not disinfect it, then you see there the bugs and grain borers at the right hand side in the maida and in the left hand side of the matki. Even in case of matki, some fungal infection is there. Some bluish greenish shade developed in the matki, because when we purchase the thing from the farmer or from the merchant, the moisture level is near about 14 to 17%. If you purchase the fresh produce from the farmer, then up to 70%. And the optimal dryness means water content, moisture content of the agricultural produce, any type of produce, if you want to have the long-term shelf life, it must be in the range of 9 to 11%. It depends on the product to product. These are the values from the microbiology lab, that is total viable count, where groundnut is tested. Before treatment, the value of the total viable count is 1,10,000. After treatment, it is 40,000. For coriander seeds, it is 1,60,000. And after the treatment, it is only 10,000 friends. How it is? Because the coriander seeds cover puffy. And when it's a soft and puffy, it is more hygroscopic. It will absorb the moisture from the surrounding. If you can have a jar, if you open it for the use, and again if you tight the lid, it will absorb the moisture from the air itself entering in that half of the empty jar. And therefore coriander seeds are very prone for the pest control. Then yellow petit means jala moong dal manto apan moong dal, in that we have 1,10,000 and it is reduced up to the 40,000. What is this, friends? Total viable count means all pathogens available in the agricultural produce. If its value is less, shelf life improves. And we have the results up to, this is after 3 months, we have tested up to 6 months also. This count is merely 10% rise. This is the time versus temperature graph for the hemispherical solar dryer, where you can see the temperature may goes up to 80 in the upper layer, and in the lower layer it may up to the 76, 78. And if you observe the time from morning 9:14, if you place it in the sunshine, the peak is at the 1 p.m. And once you exceed 60, and that is from the 11:30 approximately, 11 to 14 is 2 p.m. we have a good temperature inside the drying chamber, and therefore disinfection is there. Whatever the viable count available with the agricultural produce, that is totally killed down, and we have the good result. This is the solar radiation for the same day. Obviously, up to 4 are good, then a sharp down, maybe hazy or sometimes cloudy. But the good sunshine is that this is the total solar radiation that is diffused per direct. It is 900 plus something. In October, we have good solar radiation. This is the 1 kilogram of system. This is the market ready product. It is to be manufactured by the CTEC company from Pune. It is available in the market. We will go through the video for the same. This is the solar dryer cum disinfector, where we can add here the agricultural produce which is to be dried or disinfected, and just place the collector over the trays. We have a change mechanism in which the slit is there in the drain pipe and slit is there in the cap. When you match this slit with the slit, there is a change mode. Means the drying mode is active, and when we change the position of the cap with the perpendicular position of the first position, or we have single line engagement and double line engagement here. When it matches with the single line engagement, there is a change, and when it matches with the double line engagement, it's a dryer disinfection mode. For this hemispherical solar dryer, we are going to develop another modular solar dryer in which we have a PCB. That PCB receives the signal from the temperature humidity sensor installed inside the dryer. When that temperature humidity sensor gives a signal to the printed circuit board, and
that while through the Wi-Fi gives a signal to the handheld device or user device as a mobile, and the user can get the text message that agricultural produce or the produce kept in the dryer is ready to consume. Here, another function when it is in drying mode, then we can have on off of that blower by sensing the temperature and humidity of this printed circuit board. For the experimental purpose, this printed circuit board is made up over here in the box. But in actual practice, that can be installed over here with a small printed circuit board that can be installed over here. For the modular industrial application, that is for a large capacity dryer, the diameter of the dryer is 3 meter. That is, the single time loading capacity is of 500 kilogram. We have some tested samples of the dryer that shows you total viable count. That is how disinfection appears. For this industrial region, we have 5 meter diameter where principally saying this is the grazing and this is the absorber, and the air between this gap is being sucked by the blower and supplied to the bottom part of the tray support. These are the of the tray where we can have here for simplicity and for the understanding only one layer is installed, another layer is being installed, and one another small tray layer is being installed over here, and we can have the loading of either for the disinfection mode, that is drying mode, or some temperature based mode. We can have all pulses or some grapeseed resin or some ginger drying or turmeric drying. We can use this for the drying applications for industrial and merchant applications.
Okay, Satish sir, it is visible and audible.
Yes, sir, it is visible and audible.
And now this is the photograph from my home itself. I am using my terrace as a research lab. Alsi drying, then some dry fruits, and this is the hardest thing to dry the dates. Then we have tried some onion flakes also for the drying in the 1 kilogram capacity dryer. This is the automation that consists of as a user device controller and communication media, as we have insight from the video previously, and this is the airflow mechanism, how air is being passed from the drying chamber into the environment, and that is decided by the knob position. And this is the same that we have seen 100 kg capacity. We have developed a small blower for that. Later on, we have purchased 0.5 HP blower. That is not shown over here because air movement is very essential, vital. Same as you see in the color change. This is the 3 layers. We have developed trays in multiple options, that is stainless steel mesh, stainless steel frame, then bamboo frame and fish net, then wooden frame and a fish net, and n number of options we have tried to have a good techno-commercially viable systems. This is for that 3 meter capacity. This is exploded view where we have a tray stand, then we have an absorber, then we have a glazing, and all structure mounted on the caster wheel. We can open, how we can load the produce inside the dryer. Some highlights on the grapes drying. These are the photos from the Pimpalgaon Baswan, Nasik, Dhule, near Dhule in Maharashtra. The drying method is very crude, friends. If you look once, then you never eat the resins available in the market. The resins available from the farms collected, then fumigation is there overnight by the sulfur, then in silica oleate and dipping oil, that is a term, and sodium bicarbonate bath. They dip the carrots and then sprayed over these fishnet compartments. And in the earlier stage, for example, in today's scenario, November, December, the drying cycle may be up to 21 days. And for 21 days, to preserve the grapes to be, during the drying process, they spray that sodium carbonate and dipping oil solution over the grapes, alternate days or even daily if solar radiation is very less, and then that is produced as a resin. And for the black, the story is very bad because black doesn't have any color effect. For these grapes, they are preserving the color, therefore it is in shaded region. But for the black, they directly placed in the open air. It is contaminated by n number of things. Just you imagine what is there in the drying farms. This is the 500 kg system. Here, how it is. This is installed at the Baramati, and these are the tray supports for this system. We have 5 layers, and in the Baramati we have tested 500 kg of grapes to resin, and this is the, if you observe the color, only dipping oil is used in the rated concentration, and the colors are very lucrative and good. Chemical is very minimal, therefore it's a safe for the consumption. Then the main, my dream project comes here. This point forward, this is the large capacity hemispherical solar dryer. If we compare with the cabinet dryer and even with the solar tunnel dryer, at the right we have the system developed that is for 1 ton capacity. In solar dryer, the capacity is good, but inbuilt disadvantage we will see here, because the characteristics which we overcome, the limitations of the present technology, just we discuss and highlight. Air change mechanism in solar cabinet dryer, if you observe here, these black chimneys are there and all at the multiple places. And when you change the air, there are dead pockets or dead zone at the farthest region. And also in the left in cabinet dryer, that black spot are the blowers operated by that solar panels. And obviously, if you observe when solar radiation incident on the produce, the EV incident means the passing through the glass cover entrainment of the EV is not prohibited, therefore it affects the color aroma. And also here dead zones are there. There is no uniform air change inside the system, which affects the drying efficiency. Then air change mechanism, if you observe here, here only this single point air change valve or vent pipe is there, and here we have multiple locations exit. And if you observe in hemisphere, the air is supplied from this base, that is the air is, when it is heated through the glazing and absorbed, it is sucked by the blower, and by the blower it is forcefully supplied from the bottom circumference and radial pipes from the bottom by the force blower. For this 1 ton capacity, we have the blower of 600 CFM, and that is good enough for the force convection drying methods. Here we have 7 layers. Later on we will see how the products are loaded. And the cabinet solar dryer, if we compare with the power maintenance of the air change mechanism for the same capacity, if you benchmark our system, then the cost is more about 140, 130%. The 15S of air change mechanism, as we discussed, that is to the hemisphere, all hot and humid air ascends at the top, and it is being vented from the single point. Therefore, the air change rate mechanism is very good. It is controlled by the vent valve as per the solar radiation available, because solar radiation controls the temperature and temperature controls the drying. For every agricultural produce, there are different temperature range for the drying, and that's why the Law Foundation Dassault system gives us the grant of rupees 8.26 lakhs. We are producing the SOPs, that is standard operating procedure, for 4 agricultural produces, that is grapes to resin, then ginger drying, then banana, and lastly onions. If you consider the geometrical advantage, then for the 1 meter radius or side of the cube, the area available means for volume is very as good as twice of the cabinet dryer. Insulation, no need of insulation in our case. No need of insulation in the solar tunnel dryer also. But the cabinet dryer, only one side is covered by the transparent glazing, that is glass, and 5 sides are to be insulated. Orientation, mostly dryers, cabinet dryer, if you don't orient it due south, then there is a compromise at the type of installation. And when it is installed by the layman, they doesn't think about the exact north-south, solar north-south, and we have the compromise in the efficiency. Then obviously in hemispherical solar dryer, if you observe here, it is placed in the horizontal place, and we can have the solar radiation acceptance from the morning to evening and throughout the year. Then ultraviolet exposure, we have discussed. Drying space, obviously 100% efficient drying space is available. Disinfection capability is very good for our dryer because we can have a good temperature control. And this disinfection is now selected by the Principal Scientific Advisor, Government of India, for the drying and disinfection. In prisoners, our product is being selected because there is no proper washing of the clothes and their linens, and therefore also in hospital setups, the clinical infection nowadays is very crucial and very bad kinds. Means we can have a flu, if you admit, you can have a parcel as a tuberculosis and other like that. And that's why what is our aim? You can load your whole linens, including mattresses, your gown, and everything in the hospital setup in the dryers. There is no worry about the fire catching because temperature never exceeds 80-85 degrees centigrade, but disinfection capability is good. Obviously, no sterilization is there, but when it's humid and hot, then disinfection is very good. And this was well revealed by all of you in the corona. During corona, we have a vapor inhalation. The cost is considerably high than the solar tunnel dryer, but if we compare with the cabinet dryer, most of the sector cabinet dryers are still using because the cost is very means that systems are available in low capacity, that is 1 meter square, 2 meter square. Therefore, the moderate cost is there. But in case of our system, cost is higher side because the thermoforming is essential for the transparent glazing, then forming of the metal petals, and therefore the cost is something higher. A blower is there. Power is needed, but that power is, if you compare with the heat energy, it is only at the 10% limit. Then this is the, once again, large capacity hemispherical solar dryer. These are the tray samples over here. This is the CATIA image. We have 7 layers of the trays, and it's in crisscross, means if one layer is east-west, then another is north-south. We have this intentionally, this arrangement is there to have a large path of the air to give the maximum time of the air for agricultural produce drying, and we can have efficient drying. This figure is self-explanatory. We have a blower at the bottom. We can suck the air. Obviously, this pipe is insulated because heated air is being sucked. In case of winter, heat loss is considerably high. Therefore, all suction and up to the delivery end, the pipes are insulated. Then we can have separate controls for the distribution pipe. But later on, when we have tested, that walls are not a very crucial role in the working. Just suck the air from the crest, heated air from the crest, and push it from the bottom, and we can have the convecting drying. Dear friends, dear academicians, researchers, all of you, this is the convection mode of drying, and the convection mode is very efficient, and uniform drying is achievable by such drying mode. None of the dryer in the market gives such type of drying methods, and therefore these results are very good. Mr. Salim Huzaifa from Law Foundation Research System visited our institution during the initial stage of the development. At the back, we have a solar collector only, and the tray supports is being manufactured at that time. This is my all faculty colleagues and all students are there. So all workshop faculties are there, and our team is working day and night for that. My students working for day and night. At least 9 p.m. is the common time of our leaving the campus. such type of insulation is there. If you observe, the specifications are size is 4-meter base diameter, space required to install 15 meters square, blowers is of AC blower 1 HP, tray area 80 meters square. Here, during this development, we have says that 20 means initial stage we have only 50 meters square. Now second model we have 80 meters square. In this model we have only 55 meters square area and 20 kgs per meter square loading intensity. We can have a loading of 1 ton, and we have tested 1800 kilograms of grip. Obviously trays are from stainless steel, then automation of the air movement and some IoT supports developed by my students by using developing the app. Later on we will see how that app is working. This is the loading unloading criteria. At the top image it's in closed position, and in the bottom image over the caster wheel, that half of the hemisphere is being open either in right hand side or left hand side, and we can load the tray or unload the tray as per the necessity. Sometimes we can observe the drying progress in between also. This is the CATIA image, shows the details of the tray support. And for 24/7, we have 2-3 options basically. First is if you have a solar heated water, then this is the heat exchanger. This is nothing but the condensing unit of your 2-ton air conditioning unit, and there is a converging duct when we can supply the air into the drying chamber. If you observe at the left, this is the methodology of working, how that air flows. Air is being sucked by the blower through the heating coil. The heated water is being pushed within the coil, and air is being heated, and with the same structure available with such a circumferential pipe and radial pipe, we can pour the air for the drying. And we have tested it for this 100 kg system. Sorry. This one. For this system, this is the pipe at this black pipe at the bottom, and the radial pipes are there. Results are not very promising. Results are not there because the insulation is what was very poor, and also we have very less intensity of energy in the solar heated water. That's why now we are developing a non-cattle feed based biomass boiler. This is also part of the La Foundation Dassault system. If you observe the video, how that boiler works. The temperature is near about 70-75 degrees centigrade. Though term is boiler, but we are not creating the steam. We are heating the water only. This is being developed in the essential equipment, MIDC Dhule. These are my students, Bhavesh Shimpi and Pushparaj Devre. That is Ashok Zadav from the essential equipment. Here, what are the peculiarities or what are the characteristics of this boiler? This is the non-cattle feed biomass boiler. It's a win-win for agricultural industry because all agricultural industries having some biomass that is not used for the cattle feed. For example, cotton stack, some tur dal stack, tur stack, and all other some agro cutting or any other biomass, combustible biomass can be used as a fuel. And in the off sunshine or in the evening, we can heat the water. Though the term is boiler, but we are heating the water up to 80-85 degrees centigrade. And by using the same heat exchanger, we are now using 4 coils of the 1.5 ton AC. It is in series, multiple in, multiple out, and therefore the air is being heated, and that heated will be poured or pumped from the bottom side of the dryer. That is in progress. That this only boiler is produced, but the testing is still waiting. But as means backside results of the 100 kg system, and with the solar water heater we have good insights, and by mathematical modeling and all other we can have good drying efficiency. This is the ginger processing here, where we have raw gingers sliced, then it is dried, and this is the loaded of the gingers. This is about the grapes, 150 kg of resins produced. We have a solar, we have the tag of our institution, that is Suncrest was the title for that gadget, and these are the drying gingers. For 150 we got 22.1, means 22 kilograms, 100 grams of the dried ginger flakes. The results are very good. We have tested the resins. The content is comparable with the product available in the market without using chemical. But that what is without is not good, but with the minimal chemical, that is within the range of the WHO guidelines. Then this is the website that is developed by student. Okay, it is not working. Okay. This is the Dassault Systems logo on the website, and this is the admin panel. Then contact us. This website is being developed by my computer engineering students, Raghuvanshi and his team. Then these are the various admin dashboard and contact us messages, some blog site and product section. My students can upload the information or research data available with them, and once you go through the website, you can get the information about the SOPs developed for the various products. We have, though we have not declared the SOPs for the leafy vegetables, we are working on that also. We have tried some curry leaves and some bale patra, that for using for puja also, as for drying, and neem leaves. The results are very good. And this is the Saur Setu app developed by Kedar Joshi and other team. And here the purpose is that the Android-based blogging app showcasing the complete research work of the hemispherical solar dryer. The app uses Google Firebase to centralize all data, enabling real-time access instead of storing information locally. Means if you have an app, if you register, you can have the data from the cloud. Users can export structured research posts categorized into ginger, resins, curry leaves, or whatever the products you are drying in the solar dryer, designed to provide a clean, accessible, and research-focused digital platform. So this is the same, where we can have the in-app, we can have app website, then college website links, mechanical engineering department blogs, or some website access here, and our developers, the team available if any doubt, and then go back category. This is about the solar dryer. Once again, highlighted points, as I said, the presence of 13 to 16% moisture causes enormous growth of the grain paste, reduces to 10 to 10% by the solar drying and disinfection, may increase the shelf life up to 6 months. And also for the drying demand of the agricultural produce, n number of agricultural produce can be dried, from the dry fruits, pulses, to the leafy vegetables. Means you can dry anything, you can process something. I have used my solar 1 kilogram system for making the jam, jelly, gulkan, and other products. Also hair oil, that all with me. I'm using all these things day to day, and the results are very good. If you compare with the techno-commercial terms in marketplace, the household, the shades are not suitable, the conventional dryers are not suitable, because 1 kilogram system is not available in the market. Our system is only suitable for the small scale or domestic applications. Then commercial applications, moderate effective. Why that rating is moderate? Just because of the energy collection efficiency and the uniform drying. Uniform drying is the major challenge in the available technology in the market, and that is very. At the initial stage, I was also in the doubt when we have tested the resins. I think that at the base there should be proper drying, at the top there may not be, at in between may not be, but after 6 days everything is uniformly dried. And believe me friends, if you visit our institution, still after 4.5 months, that resins are stored in my IC engine lab without cold storage, and still the test is same. There is no harm of the test. Even ginger flakes are locally, we have you the means 50% was sell out in our campus itself, and remaining is available for the visitors to give the samples as a gift from our mechanical department. Disinfection, definitely we have studied, we discussed a lot about the disinfection because temperature is very essential, vital part for the disinfection. Process time is moderate. Cost comparison, moderate cost is basically required. Trades having very low cost, but the results are very bad. The hygiene is at a big question. Conventional solar dryers having the cost very high because the capacity is very less. If you even you compare with the heat pump based system, the energy usage is very high. For 300 kg, the per hour power consumption may up to 5 to 6 units. And if it operates for 24/7 at the current energy cost, you can compare the cost of the energy. Not only cost, it is also not environmental friendly. That technologies are not sustainable. Though the power comes from fossil fuels or solar energy, everywhere my tagline is always there, every watt is precious, and electrical energy is very high grade and precious source of energy. The user must think twice when you use that energy for the heating applications. Basically, heating applications, solar is the best part of the installation orientation. As I said, sometimes technology is very good, but at the time of installation, if some mistake is there, it doesn't give you the uh, proper efficiency or the drawing. The overall remark is that the only product which is suitable for the household to industrial applications. No doubt, some difficulties, some problems are there. And down the line, when we work together, you and me, for down the line 2 3 years, all problems are being sorted. Some problems are there, manufacturing difficulties are there still. Some loading unloading is sometimes maybe need some crucial attention. Layer wise, some tray variants are there. 4 types of trays are there. Circumferential curve trays are there. And all trays are manufactured from the stainless steel. The tray manufacturing is still very tedious. Afterwards, by automation, we can have the solution with us. Project objective, definitely these objectives means when I submit the proposal to the lab foundation, then these are the objectives for generation of SOPs, then for loading intensity, for the selected products, then disinfection capabilities for hospital setup. It is also part of the research. Still, it is in the progress. We have to install it at some hospital setups in the Dhule and in government hospital also for disinfection of linen and all usables of doctors, patients. Even you can load the physical part like a stool, shelf, compartment, cupboard, and your cot also in the solar dryer of the 4 meter capacity. Then agricultural produce, okay, tested. Even for dry fruits, friends, if you think about the almonds and cashews and that mainly pistas and all that things. Basically, acroad is the very prawn product for the infectious content, and we have tested that acroad, and the shelf life is input up to 2 3 months. And obviously, we have the simulation model with us, Pune based, because the grant itself covers the numerical solution simulation cost in that grant. These are the awards, patents, grants, then awards in NET, HTS. Our college have American Society of Materials affiliated Material Advantage chapter, and that chapter visits after alternate years to the MET, STS, that is Material Engineering Technology and Heat Transfer Conference. This is very good conference, prestigious conference conducted by the ASM, American Society of Materials, India chapter, controls all the, and we have presented our technology at their innovation pavilion, and we're happy to show you that in 2022 also, and in 2024. In 22, we have first and second prize of 1 lakh of rupees. And in 24, in 22, I was not there. In 24, he was there. And from the Innovation Pavilion, all first, second, and third International Innovation Pavilion prizes are won by our institution, that is of worth of rupees 1 lakh. Student publications are there. Faculty publications is by default we publish the papers and research publications, but my students also have the research publications. In the May, we have a media publicity in all printed and social media. It is well appreciated by starting from C channel to IBN to the Star Maza and Doordarshan, all that. This is the letter from the Law Foundation about the granting the grant of is 8.26. I'm very much thankful to Law Foundation Dasal System for giving the grant. Institute also have the share of 3.5 lakhs of rupees, and we have research going on. Still, it is in progress. We are making another system. I have that photograph, but not inserted here. With the 11 layers, we have now 80 meters square and the average loading capacity of 12 kg for the slice product. Because when it's a part of lumps, for example, for the grapes, we can have 20 kg per meter square loading. But when it's come to the slices of the banana and ginger and other products, papaya, then it comes to only 12 kg. These are the patents, modular solar dryer and simple basic version of the dryer, patent granted in India twice. Both are utility patents. These are the patents filed in US, Indonesia, Vietnam, and Malaysia. Obviously, I have the investor for this. These are the Dule TV, Ava. This is a C9 news. This is in Hindi basically.
समापन। आगे बात करेंगे कल्याण के जहाँ होकर कार्य करना आवश्यक और बजरंग दल के स्वर्गीय परमानंद वाद हिंदू धर्म के प्रति सफलता के
कार्रवाई करता है। पुलिस का सहयोग कार्यक्रम के भाग
हो गया है। ये सोलर ड्राइव एक टिकाऊ गैस मिश्रण प्रणाली, ये दोनों शोध कृषि, स्वास्थ्य सेवा और आम नागरिक के लिए बहुत उपयोगी होंगे। ये अखिल भारतीय सोलर ड्राइव किसानों के लिए कृषि प्रसंस्करण उद्योग में एक बड़ा बदलाव लाएगा। इसकी मदद से अंगूर से किशमिश, अदरक, प्याज का पाउडर और हरी पत्तेदार सब्जियों को सुखाना आसान हो गया है। ये सोलर ड्राइव किसानों को बिजली बिल की समस्या से पूरी तरह मुक्ति दिलाता है, क्योंकि ये उपकरण पूरी तरह से सौर ऊर्जा पर आधारित है। दिलचस्प बात यह है कि ये प्रसंस्कृत वस्तुओं के प्राकृतिक स्वाद और रंग को बरकरार रखता है। इस उपकरण के निर्माण की लागत अब तक 2,75,000 हो चुकी है और फाउंडेशन द सॉल्ट सिस्टम द्वारा 8,26,000 का अनुसंधान अनुदान स्वीकृत किया गया है। कॉलेज के अध्यक्ष दादा साहेब सुभाष देवरे ने इसे अर्थव्यवस्था के लिए गेम चेंजर कहा है। श्री शिवाजी विद्या प्रसारक संस्था के अध्यक्ष विधायक कुणाल पाटिल, कॉलेज अध्यक्ष सुभाष देवरे, प्राचार्य डॉक्टर हितेंद्र पाटिल और मैकेनिकल विभाग के प्रमुख प्रोफेसर डॉक्टर संजीव दामोदर सूर्यवंशी के नेतृत्व में एक टीम ने इन अभिनव नवाचारों का निर्माण किया है। इस सोलर ड्रायर और टिकाऊ वायु मिश्रण प्रणाली के विकास में कॉलेज के अध्यक्ष सुभाष शिवाजी राव देवरे, प्राचार्य डॉक्टर हितेंद्र पाटिल, मैकेनिकल विभाग के प्रमुख डॉक्टर संजीव सूर्यवंशी,
विभाग प्रमुख श्री शिवाजी
आहे ना, तालुक्यात इतक्या महिला करताय। कांद्यासाठी पण खूप छान आहे, मला आता मागवायचं आहे।
मी प्राध्यापक डॉक्टर संजीव दामोदर सूर्यवंशी, मेकॅनिकल इंजिनिअरिंग डिपार्टमेंटचा विभाग प्रमुख श्री शिवाजी विद्या प्रसारक संस्थेचे बापूसाहेब शिवाजीराव देवरे कॉलेज ऑफ इंजिनिअरिंग धुळे। आम्ही हे 4 मीटर डायमीटरचे हेमिस्फेरिकल सोलर ड्रायर बनवले आहे, ज्यामध्ये 1 टन क्षमता आहे त्याची। एखादी वस्तू ड्राय करायची, फॉर एक्झाम्पल आम्ही इथं द्राक्ष ड्राय केले, ते 1 टन ड्राय करून बघितले। पर्यावरण पूरक हा प्रयोग आहे, शेतकऱ्यांना उत्पादन खर्चही कमी येईल। तसंच सेल्फ हेल्प ग्रुपचा भाग आहे, ही पेटेंटेड टेक्नॉलॉजी आहे। भारतामध्ये याचं पेटेंट ग्रांट झालं आहे आणि मलेशिया, व्हिएतनाम, इंडोनेशिया आणि USA मध्ये सुद्धा याचं पेटेंट थोड्याच दिवसात मिळणार आहे। आपल्याकडे काय वी हॅव लेस टाइम Satish sir given me only 1.5 hours, and we have to. These are the awards from the various societies. This is the printed media coverage for solar dryer. All printed media around Dhule and also state level news was trusted there. Uh, for after the solar dryer, Satish sir, we can have a 2 minutes break for the QA.
Yes, yes, sir. Yes, sir. No problem.
Then we will proceed towards the other technology.
Yes, yes.
If any question, please audience, you can ask me.
Dear participants, if you have any question or a dialogue with the Dr. Suryoshi sir related to dryer, solar dryer, so please unmute yourself and discuss with the sir. Or you can write into the chat box. So in chat box, there is some question.
Please, you can spell, sir.
Please share the details of solar dryer. Likewise, some participants is asking which type of
Yes, sir.
solar panel is used and how much is rating for solar panel and required to build a solar dryer. Which type?
Basically, this is based on solar thermal application. No solar panel. We are use still date. We are using the directly AC power from the MSAB supply. We are using the solar energy for drying, not electrical energy. Electrical energy is sufficient required for only operation of the blower, and it is also intermittent operation that is by controlled by the timer and temperature controller.
Yes. Participants, if you have any queries or question, you can write in the chat box or directly unmute yourself and ask to the sir. Okay, I think
I have to share. I have to share another. I have to stop sharing now. I will share my different screen. Please wait a while. Sir, screen is visible?
yes, sir, visible.
Okay. Now, dear friends, this is another domain for the sustainable development, that is energy efficient building. This is all about the story of my house that is built at 17 Anmol Nagar, Dhule. If you consider the climatic zone, we are hot and dry, hot and arid climatic zone in the Maharashtra. Dhule is located. This is the today's real condition. We are using air conditioners, and we are afterwards we are increasing the temperature, and the sufferer is always at the counterpart of our healthy lifestyle. In energy efficient building, the thermal comfort and also sometimes power cut is very crucial for the buildings where heat gain is very high. Specifically in the buildings where we have a rooftop by the sheet metal or some RCC slab with the improper management of air change, then the inside condition is very worse. Also, this ventilation system is cost effective, and we replace the hot stall used air, means where the oxygen level is very less or some contamination from the inside whatever the storage you have. For example, in storage places, in the warehouses, if you enter through the if you enter in the home in the city regions, you can detect the morning fenugreek sabji at the evening also, because there is no proper air change inside the building. What are the projected outcome? Basically, aerated autoclave concrete bricks having good insulation value at the surrounding, then reflective foil insulation, then thermal mass management, color selection at the outer covering envelope. Then thermal comfort is very challenging in the building, in residential, hospitals, in industrial estates, in poultry, all over. The crucial parameter is air change. And if you maintain the proper air change, predefined air change within the occupied space, then we can have a fresh air intake and we can manage the temperature. The energy efficiency is another crucial parameter because the system developed for the ventilation by us is using zero energy, and also due to some thermal mass management and building orientation, some design modifications, we can have the reduction in the heat gain from the covering envelope. Case studies, we have number of case studies here. One is about my own home, then Tambak Nagar in Dhule, a halwai shop, then room number 317, where we have the evaporative cooling pads assisted with the air change. Then installation at the Beed Vadarvasti. This is from the grant CSR grant of the IT sector. Then installation of bubble sheet as a false ceiling at room number B341 at our SSUPS BS Devre College of Engineering, Dhule. From this point forward, we have a grant of rupees 4 lakhs from the La Foundation Dasal system for the sustainable ventilation. And then next work is proposed work, but now it is also done partly. More or less 90% work is over in room number B317. This is my own house where you can see the solar chimney at the top. It is at the center. These are the highlighted criteria for the building orientation, thermal mass management, solar water heater, solar dryer at that time in 2002, external surface texture, its color management, vented cavity wall, windows, then lighting, and in air conditioning. Basically, air change is very crucial, and that is achieved by the solar chimney and ducting inside the house, also assisted by the turbo ventilator, and in overall assisted by the evaporative cooling, which is the major cost-effective solution in the hot and arid climatic zone like Dhule, Rajasthan, Vidarbha. This is the layout. Hello. If you think about the layout, if you have a plot size like this rectangle, the east-west axis should be major if you want to build your house. This is the ducting in my house. We have 4 rooms. If you see from the top, we have a hall, then we have a bedroom, then we have a kitchen. Basically 2 beds. One is at the northwest and one is at the southwest. And this is the kitchen this is the ideal location of the Vastu Shastra construction. Basically, this is the inside view of my house. This is the kitchen. This is extended plenum type ducting system. This arrow shows the passage of the air, and this is the main duct. This is why it is extended plenum, because branch ducts connected to the main duct and air flows from this occupied space. This is the one. Then this is the hall. This is the hall ceiling having intake of the air. Then this is one bed where grills are there for sucking the air. How air is being sucked, we will see later on. From 2 beds and from the hall itself, air comes to the junction box, and from the junction box, this is the 4 layout. This is the hall. At right top is the hall. At the left is the bedroom, and also at the bottom is the bedroom, and this is the junction box. And exact above the junction box, we have a solar chimney. The chimney is about 14 feet. It's a blackened. Its location is so designed that it will expose to the solar radiation maximum time after the February. Because in Dhule, March, April, May, June, July, August, September, the crucial the solar radiation intensity is big, up to 900 watts per meter square. As you see in October, we have 900 plus. And then one modification is there. We have a turbo ventilator installed at the top. This is the solar chimney. Now this house is modified. We have 2nd floor. In 2nd floor also, we have maintained the air passages in the beam and in the compression zone by consulting with the civil engineer, and we can have air passages from the both the floors into the environment. This is the flow physics fundamental. Cold air heavier than the hot air, therefore it enters from the bottom, hot air rises, and then it flows to the top and vented into the environment. Then this is the cavity wall. This cavity wall, bottom vents are there, top vents are there. The cavity wall is constructed on the west side and the south side. At the right, you can have the sectional view of the cavity wall. We have a bottom vent, air is being ascended through the cavity, and then from the top vent, it goes to the environment. What is the purpose of such construction? It reduces the heat gain from the wall side. Because in summer, in July, the surrounding temperature may exceed up to 45. In diffuse area, also the temperature is 40 plus, and therefore that heat gain is considerably high. Therefore, when outer lip, this is the lip terminology, means outer wall is being heated during the day, and the air entrained between the cavity is also heated. If you vent this air, then heat gain in the building is reduced. First time in the world we have heard this concept, vented cavity wall. These vents can be closed in the winter only to reduce the heat loss from the building itself. Then this is the damper at the chimney bottom. It's a central damper, because if you observe here, these are the strings located over here. If you observe the left top image, this line itself as a string, and the walls can be operated by the hand. Just by gravity principle, that walls can be operated on and off. Zoning is there. And this is the central stop for the winter. If we close it, then whole warmth is being preserved inside the building, and we can feel the warmth. But in summer, you have to open the central damper and the internal dampers as per the requirement of the zone. If you use bed only, you can have the air change from the bed only. And preferably from that side, we have evaporative pad located in the windows, and we can have cooling. The water on that evaporative pad is being used by the drip irrigation. Damper open and close position. At the initial stage, solar water heater is built at the top of the staircase tab. This is the top of my staircase cap. More or less 20 years I have used this solar water heater. It is just by the grid of the pipeline, GI pipeline. One invention here also, the fins are from the bottom side. In the flat plate collector, in the market, the fins from the top, which imposes additional resistance for the heat transfer. If you see at the left top corner, there is a window. That window is being used for the, if you see here, this is the window at the left image. This window is loading and unloading for the drying purposes. 20 years I use this solar collector as a solar dryer for my household uses. All that dates and all things. This is the bottom part. We have added here some iron powder with some binder to have an integrity for the conduction. This is the top plane view of my staircase top. If you see here, this photo is of 2013. Basically, one modification was there because water leakage problems are there. Some civil construction limitations for such type of technology. If you observe here, this is the handle and this is the drying access to the drying chamber. From the bottom side, if you observe here, I will load here. I can load here at least 10 kg of grains that are contaminated if you want to disinfect. This is the pipeline for the water heaters. Basically, I have applied only a very raw insulation because this is the visitor place for the college, diploma, degree, and school students, just to show them what is the solar heat application technology. It's not a rocket science. It's only physics we can apply for this. This is the photographs of the 2002. My students from, I was in Polytechnic at that time. These are my Polytechnic students. Myself, a plumber is there, and my son, now he is MD Medicine from the Amrita Kochi. He is also working with me for that time. He is observing. We have a banana sockets and temperature sensors at that time, 2002. And this is another AME pot. Here is the pot in pot. Actually, if you observe, this is the good image. This is the inside is the cold storage, and the outside annulus having the drinking water. Water can be used from the tap. And this is the zero energy refrigerator being used in. This is the water filter that is just by the gravity. No freeze or mist water is directly used from the tap for the drinking purpose. Then this is the second case study, that is for the Halwai's house. This is the case study at the Beed, Vadarvasti. We have it's all about the bubble sheet. Actually, this work initiate my research by for using the bubble sheet as a false ceiling. Bubble sheet is nothing but a both side reflective foil covered with the plastic bubbles, and it acts as a insulating, both as a it reduces the conduction, and also by radiation it reduces the heat gain from the sheet metal rooftop. This is a 17 Anmol Nagar, that is my home. We skip this because we have scarcity of time. This is the CATIA images, how the wall ceiling can be installed below the rooftop. Specifically, if it's a sheet metal rooftop, then we have a solar chimney for air change. Obviously, purpose is same. We have to maintain the predefined air change from the occupied space. Then this is the case study third, that is room number 341. And for this project, as I said, the La Foundation Dasa system offers the grants of 4 lakhs of rupees. This is the material used for the anchor bolt, angle clip. Then this is the bubble sheet. You see here, this is the sticky tape, and this is GI wire for supporting. This is the room view before installation of the bubble sheet. We have openings of the air change rate, and then this is the covering of bubble sheet. There is a flap opening for control air change rate in the winter and summer as per the requirement. This is the GI wire grid to support the bubble sheet, because the flexural strength of the bubble sheet is very less. We have to support it uniformly on the bottom. And we have added here the glass with the reflective foil. In my house, I have purchased the reflective coating, bronze coating glass from the Saint Gobain for the first floor, and the heat gain is very much reduced. This is work in my college in SSUPS, that is room number 341. If you observe the band, without glass, such band is there. With the reflective foil, that right hand side band is there. How that direct radiation is being reduced, because that direct radiation carries not only light part, it also carries heat energy, and we have to tap that energy. And this is the 24/7 graph plotted for the room number 341. If you observe, the temperature may excess to 35. This temperature, this blue line is the temperature above the fall ceiling, that is bubble sheet, means which faces the fall ceiling. If you have no bubble sheet, then this may be temperature you have to face. But when we are using the bubble sheet, we have 1, 2, 3 layers of the temperature measurement. We have data logger, thermocouples, then micropressure sensor, and we have a number of supports for the measurement. And here, obviously, from 35 to 29, more or less 5 to 6 degrees centigrade drop. Before evening, you can have the reduction in temperature, and in the night, you can have higher side temperature. Means it is not useful for day only, but it is useful for the night part also in the acute winter condition. Means this gives you 24/7 application. Dear friends, if you observe here, no energy is necessary, because at the top we have turbo ventilators, and this is the measuring process we have adopted in our room. And these are the achievements. 7 degrees centigrade drop. Then this is the simulation results for the same. How that can be simulated. These are the dimensions. Then after we have in simulation, the Ankit Khandelwal help us. I'm not mastering the simulation, but one MTech student from PCCU, Mr. Sumit Hire, is a research scholar with me, and I'm from Dhule and in Pune, and therefore I started my presentation. Nowadays we can have the solutions at fingertip. We can have good accessibility for the research all over the Maharashtra, all over the India, or also from the globe. And these are the images, self-explanatory images, how the temperature is, profiles are there, means our path lines, temperature weighted, and then pressure rated. This is the domain. Obviously, the cell count is very high, therefore it consumes a lot of time and energy for simulation. but the results are goes hand in hand with the experimental results, and that is a win-win for the researcher. This is also well appreciated in Avishkar, then ESAIL IIT Mumbai startup competition. One of our group presented there, and they have the golden pass up to the state level, and then and also MET HTS. This project got the second prize. This is the website of sustainable ventilation developed by the here we have used the outsource agency. This is our Innovation Pavilion presentation at the Mumbai. Then this is my first floor location here. These are the passages in the beam in compression zone, and here's the chimney location. This is for present means a previous work. Now it is demolished, and we can have chimney at the second floor. This is our inspiration, Das Subhaji Devre, our Pracharya Hitendra Patil, and La Foundation Dasa System, one of our colleague Karajkar, my students, their details. This is the MET HTS photograph where we grab that prizes and this is the Eureka, that is basically ESAIL initiative by the IIT Mumbai, and so on. We can have our project, our policy. We have the consultancy for the ventilation, building ventilation based on the solar energy. Obviously, friends, then when the visitors visited our place and they said, sir, this bubble sheet is not looking good from the bottom side, do something. And for that initiation, we have changed our research methodology, and we have applied the bubble sheet. What is going on? Okay. The response time is very less. Now in this project, actually we uses the fall ceiling, which is above the fall ceiling present available fall ceiling. This is the lining of the bubble sheet.
Screen is not visible, I think.
Screen is not visible, sir.
Just now, I think it's not visible.
Now?
No. I
No?
think just please share your screen, sir, first.
Okay. But screen is okay. Entire screen. Now
Visible, sir.
okay. Okay, this is case study, another case study for that is at room number 317 at our institution. Sir, this is the hall where at that time when you are working, that physics hall 317,
Yes.
1800 square feet, and here this hall is a huge capacity of 1800 square feet. This is the present fall ceiling. We have applied bubble sheet from the top, and we have air change mechanism from the bottom. Here we have the measuring setup. We have collected numerous data here. Micropressure sensor, what is the pressure drop in the ice place, then turbo inflator speed, its correlation with the wind velocity, how air changes there. And for this project, we have used this window covered with the wood wool pad. From the outside, these are the wood wool pads. We have the deep irrigation pipelines. Also, we have some covering on the sheet metal rooftop to reduce the heat gain from the covering envelope. And these are the graphs which shows the temperature variation of sheet metal. Believe me, the temperature at 1 p.m. is 65.5 for the uncoated sheet metal, and when it is super coated, the temperature is below 50. 15.5 degrees centigrade temperature drop takes place just by covering the sheet metal by the reflective. It's a ceramic coating, and there ceramic coating is supported and sponsored by the Gang School Technology. Mr. Bise from the Mumbai, he is also ASM member. He offered us that whole kit. And for the fall ceiling part, if you observe the temperature with bubble sheet and without bubble sheet. Without bubble sheet, the fall ceiling temperature up to 45, and with bubble sheet goes up to 37 at max. Means here, this is the temperature drop, and if you use the evaporative cooling, then the temperature drop is up to 9 to 10 degrees centigrade. Up to this also, Satish sir, we can have a 1 minute break to have a question answer session.
Yes.
We have 2-3 minutes only. Just I cover the hemispherical solar water heaters being patented in India, US, and China. I think we can have the QA later on. This is the hemispherical solar water heater. Here, if you observe, this is the current technology in the market. That is the ETC and the flat plate collector. Some another technology is being powered by the syntax in the market, but this is very dangerous. The capillary is broken and the balloon shape was there, and therefore the technology is being recalled by the syntax and the technology fails. Here, this is the hemispherical water heater. Same, it accepts solar radiation from all sides. The highlighted point is hot water tank within the collector. The n number of people say me, this is not possible, sir. Water cannot flow against gravity, but yes, that water flows from the top of the collector within meter means collector zone in the hot water tank, and we can have good results. The footprint area is very less. This is the development stages of the hemispherical. This is 100 kg system installed in our institution. Then we have a tubular system. We have 75 liter, 500 liter system. This is 500 liter system is in force mode. The 75 liter system is natural mode. These all comparison for the, and the last, this is being called by the Ministry of Defense now. This is foldable cum portable solar air heater. Here we have the absorber inside, then we have a glazing. This whole structure is being assembled and disassembled in 4 minutes. Means and we can have a 2-3 bags with us. It can be thrown by the air for the defense application in the Leh Ladakh Siachen border. My soldiers can just install it. Here the blower is there, but that blower is being used, can be driven by the solar flat plate collector. That is solar photovoltaic. And here some part of reflection is there. This is the working of foldable pump portable solar air heater. This is the basic version, very small as an umbrella. Then we have developed it for a large capacity that is not shown over here. These are the patent details for all. This is the MET STS award winning ceremony of 2022. Then this is the US patent. Then this is the US patent, looks like this. This is utility patent. This is hemispherical water heater in India. This is in China. And all about my presentation. I have to finish it because time is over. Exact 9 is there. If any question, I'm ready to answer. I'm very happy to share my knowledge with you, friends.
Yes, sir. Thank you. I think today we get the knowledge related to different aspects, like a solar collector, solar dryer. We know that, but the hemispherical solar dryer is a new thing, I think, for me and most of the participants. And you did a lot of work in this particular field. So we get good knowledge, and I think hope in future also our participants will want to work this particular topic. So they will be definitely contact to you for the collaborative work.
Definitely, I will share my email. If anyone having some doubt, ask me by mail, by WhatsApp, by phone. I'm always ready.
Yes.
1-2 minutes. If someone asks 1-2 questions, definitely
Yes.
I will.
Yes, so participant, please, if you have any interaction with the sir, so it's open to all. Please unmute yourself or write in chat box. So someone is asking related to what is the price of that solar dryer, hemispherical solar dryer.
Yes, if it's for 1 kilogram, it is of 2,999, means 2,999 for 1 kg, and for 1 ton, it is without trays, it is 2.74 lakhs.
Okay.
Without trays.
Participants. Okay, sir, I will share the details with
Okay, sir, I'm very happy. I always end my presentation with this, my very useful slogan that is engraved in my mind in my childhood education. The woods are lovely, dark and deep. The woods are lovely, dark and deep, but I promises to keep before going to sleep, before going to sleep. याचा मराठीत अनुवाद असा आहे सर, जरी रम्य दाट वन राई जरी रम्य दाट वन राई तया कशी घोटाळू मी बाई त्या शाश्वत निद्रेपूर्वी मनी कार्यपूर्तीची घाई मनी कार्यपूर्तीची घाई. Thanks for patiently listening, all of my colleagues, academicians, researchers. I wish you all the best for this FDP conducted by the Nutan College, the efforts by the Satish More sir. I'm very much thankful to the organizers, specifically Satish sir, to give me opportunity to present my work in front of you. Thank you. Thank you. Good night.
My pleasure, sir. Yes, sir.
Okay. Shall I leave, sir?
Yes, sir. Yes, sir. Thank you, sir.
Thank you very much.
Yes. Dear participants, thank you for your attendance for this 2 session. Within 5 minutes, I will share the feedback link in our WhatsApp group. So now you can leave the meeting.